So guys, give me 2 minutes. I'll just start. So, okay, guys, I was just starting my Jupyter notebooks. Meanwhile, I can see most of you have joined in. So today we are going to start with the details about regression analytics. And in regression analytics, what are the different options that you guys have? Okay, what are the hyperparameters? What are the formulae or the equations which are behind these? Okay, so we are going to talk about it. Okay. So before we start, a few important things. I will tell you, okay, about the hands-on. I'll tell you when you have to start. Maybe towards the end of the session today, or probably from tomorrow, you will be doing it. Okay, guys. But few important things before we start the class. The first thing is definitely we are talking about what? We are talking about regression analytics. Regression analytics is of mainly two types, okay? Linear and non-linear, okay? So इसका मतलब क्या है कि आपको जो टारगेट वेरिएबल दिया गया है वो टारगेट वेरिएबल आपके फीचर रिलेशन बनाता है या एक नॉन लीनियर रिलेशन बनाता है. इसका मतलब क्या है? अगर आपको ये प्रेडिक्ट करना है कि मेरी सेल कितनी होगी, फॉर एग्जांपल मेरी सेल बढ़ेगी या घटेगी ईयर ऑन ईयर बेस्ड ऑन दी मार्केटिंग कॉस्ट, मैं मार्केटिंग पे कितना पैसा लगाता हूं. ओके, तो मार्केटिंग पे जितना पैसा मैं लगा रहा हूं, अगर मेरी सेल उसके साथ स्ट्रेट लाइन बना रही है, स्ट्रेट लाइन, इट्स अ लीनियर रिलेशनशिप. ओके, so that means I can go with linear regression. Okay, linear regression can be OLS, which is the most common. Can anyone ping me the full form of OLS? For linear regression आप लोगों ने OLS ही किया होगा. OLS की full form क्या होती है? Ordinary नहीं. Can anyone try? Yeah, Pragesha, correct. ordinary least squares. Least squares means minimum error. Okay, the minimum error. You are trying to fit a regression line so that you get least error, minimum error. So ordinary least squares or method of least squares, that's one thing. But if you go with the advanced linear regression models, you talk about ridge, lasso, and elastic net. Okay, so this is about linear regression. Then what is non-linear regression? Anyone heard about non-linear regression? Any model for non-linear regression? And I'm talking about model, okay, not algorithm. We talked yesterday. Model is different, algorithm is different. So कोई model आप लोगों को पता है non-linear का? Okay, I'll take it. It depends on the kernel. The kernel that you use in SVM, yeah. If you use which kernel in SVM helps you to do non-linear, because there are linear kernels in SVM also. Okay. Yeah, RBF, radial basis function. RBF, correct. Other than that, very good, Nishtha. Polynomial. So polynomial regression, guys, there is polynomial regression, which primarily is one of the major models of non-linear regression. Sigmoid is a formula, definitely, which is used. Sigmoid, Nishtha, is not exactly a model, but it is used. Okay, but it's fine. Yeah. Okay. And there are other nonlinear models also, like Poisson model. Okay, that you guys are aware about a few things. So OLS, ridge, lasso. Nonlinear, primarily we talk about polynomial. Okay. Poisson. No, these are models, guys. These are not the kernels. Okay, I'm not talking about kernels. Go up SVM. I'm not talking about kernels. I'm talking about polynomial model, Poisson model, SVM model. Internally, they may use different formulae, which is a different thing. They can have a different formulae or a different algorithm, which is a different thing. But these are the models. Okay. So one of the very simple example I can give you here right now is, again, if your model instead of a straight line is something like, say, a curve like this, okay, an exponential curve, that as you increase the marketing cost, your sales is initially increasing by a small amount, but then it starts to increase very high. Okay, then it become an example of polynomial or Poisson kind of a regression, where it's not a linear relationship between your independent and dependent variable. It is rather a non-linear. It is a non-linear relation. If you see, it's not a linear line. It's a non-linear curve or a graph. It can be anything. It can be something like a sine wave. That's a different thing. It can be a squared function. Like if we talk about polynomial regression is of what? See, polynomial regression का formula कैसा होगा? अगर आप normally कहते हो y is equal to mx plus c, अगर आप normal scenario में y is equal to mx plus c कहते हो, तो यहाँ पर y और x के बीच में एक linear relationship दिख रहा है मुझे. But अगर मैं इसको x square कर दूं, x square, that means y और x के बीच में एक नॉन लीनियर रिलेशनशिप है. नाउ ये x स्क्वायर भी हो सकता है, x क्यूब भी हो सकता है. सो व्हेन यू हैव सच काइंड ऑफ इक्वेशंस, ये आपको प्लॉट करके ही पता लगेगा, सीधा पता नहीं लगेगा, तो हम उसको नॉन लीनियर रिग्रेशंस कहते हैं. पॉलिनोमियल, पॉइसन, SVM and a few others. But yeah, this is just for your knowledge. We will be focusing on the linear regression, okay? OLS, ridge and lasso. So Gulzar, yeah, ideally there are two, linear and non-linear, but within linear and non-linear there are multiple models, okay? And each model have their own algorithm. So broadly classify you can do based on linear or non-linear, that's it. However, you will hear about more type of regression as you guys grow in this field. What is stepwise regression? Okay, there is a stepwise regression also. There is something known as forward and backward regression. Okay, so these things also you will hear as you progress, but we are not talking about these. Stepwise regression, forward regression, backward regression. शायद ये आप लोगों ने सुना होगा, forward backward regression. So there are a lot of other things, but okay. So regression की जब भी हम बात करेंगे मतलब मेरा टारगेट न्यूमेरिकल ही है, ठीक है, सिर्फ न्यूमेरिकल टारगेट है. बट नाउ द क्वेश्चन इज कि लॉजिस्टिक रिग्रेशन का नाम तो रिग्रेशन है, बट यू कैन नॉट यूज इट फॉर न्यूमेरिकल टारगेट, ओके, or rather you should not use it for numerical target. There are some important things here. I'm just telling you because we will talk about logistic regression later. But logistic regression is not a regression model, guys. It's a classification model. Okay, remember. Logistic regression का नाम है regression, but it is not used for actual regression. मतलब जब आपका target न्यूमेरिकल होगा तब हम इसे यूज नहीं करते. जब आपका न्यूमेरिकल टारगेट है, वी डोंट यूज इट. वी यूज इट व्हेन द टारगेट इज कैटेगोरिकल. ओके, कैटेगोरिकल टारगेट, नॉन न्यूमेरिकल टारगेट. रिमेंबर दिस. इसके पीछे रीजन क्या है वी विल टॉक अबाउट. बट लॉजिस्टिक रिग्रेशन is known as a regression model, but it is a classification model. Okay, मीन्स आपको प्रेडिक्ट करना है कि मेल है या फीमेल है, आपको ये प्रेडिक्ट करना है कि ये फ्रॉड है या नॉन फ्रॉड है, आपको कुछ भी कि ये मेरा लोन डिफॉल्टर है या नॉन डिफॉल्टर है, कुछ भी इस तरह की चीजें जो कैटेगोरिकल है. 0-1 जब भी इन द फॉर्म ऑफ 0 and 1 है तब हम इसकी बात करेंगे. ओके, forward regression is like forward selection, correct. It's just different names in the field. Okay, some people say forward selection, some says it's backward selection. That's fine because it works on the selection of features. Okay. Okay, so again ये चीजें मैं इसलिए बता रहा हूँ कि आपको confusion ना हो when you are studying deeper. Okay, so now we are again back to the linear regression, and there is OLS, ridge and lasso. These are the three. Now we will be talking about the need, like why the need of ridge and lasso came. Okay, so as you guys are already aware about, और हमने कल भी बात की थी कि OLS या ordinary least square method internally have an equation y is equal to mx plus c, where our whole purpose is to calculate this m, right? Because this m is nothing but my slope or my coefficient, whatever you want to name it. It's a slope or a coefficient. Okay, so the entire purpose of training, the training purpose of the model is to get this value of m. So there the training data plays an important role, because if training data is not good, you may not have a correct value or a good value of m. Okay, that's one thing. And the process or the algorithm that internally works to identify the value of m is the gradient descent. Okay, and gradient descent internally uses something known as the convergence process, right? And the convergence process works on j of theta. Okay, let me say j of theta. So ultimately this j of theta is my cost function. Okay, so if someone asks you in the interviews this is how you have to explain these things. Okay, like they ask you to explain OLS, this is what you have to explain. You don't explain, okay, OLS, we train the model, we test the model. No, no, no. You have to tell what is the objective of the model. Objective is to find the slope. Now to achieve this objective, what is the algorithm? The algorithm can be said as a gradient descent, which uses the purpose is to minimize the cost function. Okay. Then they ask you what is the cost function. So cost function is j of theta. Then they ask you what is the formula for j of theta. So j of theta is nothing but RMSE. Root mean squared error. Okay, you all are aware about this. RMSE. Okay, so my purpose is to minimize the RMSE or the error. And that's where yesterday we were talking about a graph for j of theta with respect to theta, where theta are my coefficients or the slopes that I have to calculate actually, or this can be said as m. And then this graph is actually the graph of RMSE, guys. The RMSE formula actually gives you this graph, okay? Because this is what your J is. And that's where now you try to jump towards the global minimum. And this jump, each and every jump, we yesterday talked about a hyperparameter, which is max iteration, right? So this max underscore iteration is a hyperparameter which we can modify. There is another hyperparameter which is alpha, which is known as learning rate. Okay, learning rate is very, very important in the field of data science. Learning rate says like how fast you want this convergence to happen. Okay, इसको ऐसे मान के चलो कि एक बच्चा है जिसको एग्जाम देना है और कल उसका एग्जाम है, उसने कुछ पढ़ा नहीं है, ठीक है, तो आप उसको बोलते हो कि भाई जल्दी जल्दी से जितना पढ़ सकता है पढ़ ले ऊपर ऊपर से. Means with a very high learning rate he will be learning very very fast. Okay, मतलब जल्दबाजी में learning rate of 100. तो जल्दबाजी में अगर काम करेगा वो तो he will not be able to get good marks. Okay, because he will not be able to reach the global minima. He will be just trying to jump, but he will, instead of reaching here, he may reach here, land here, because he's taking up bigger jumps. Instead of taking smaller jumps, he's taking big jumps. So say he is here, but in the next jump he reaches here, which is another error area. Instead of reaching near to the global minima, he jumps here. Then he may again try to jump. That's a different thing, but he is just jumping very fast. He is reading books very fast, right? So that's the thing. बट अगर आप स्लोअर लर्निंग रेट रखोगे तो प्रॉब्लम ये है कि मान लो उसको 10 बुक पढ़नी थी, वो बेचारा एक ही बुक पढ़ पाएगा क्योंकि ही इज जस्ट फोकसिंग ऑन वन बुक. तो उस केस में ही नीड्स मोर टाइम टू कंप्लीट दोस 10 बुक्स, राइट? तो अगर आपने लर्निंग रेट बहुत कम रख दिया तो आपका मॉडल हो सकता है 10-10 घंटे तक चलता रहे. इट विल बी वेरी स्लो बिकॉज आपने उसे बोला तू टाइम ले, आई एम गिविंग यू द टाइम, बट देन इट इज very slow because model is not taking bigger jumps. Model is taking very minute ant like jumps. Okay, but the good point will be it will reach closer to the global minima. But the problem is I don't want that. That's why we select an optimal value of alpha. So by default alpha is 1, so we keep it 1, but we can change this to a higher value which will not give you good results, to a lower value which will give you good results but will take too much time for convergence. Okay, so these are about some of the important hyperparameters you should remember. Okay, you can see these in the models as well. Okay, but now ये तो हमने बात कर ली OLS की, but the question is why I need then ridge or lasso. So let's understand that. Okay, ridge and lasso you want to understand. Okay, so I need to explain you the formulae before I tell you this. 1 second. This ridge and lasso things can be done with that. Okay, so guys, what was the problem with the OLS model was कि OLS मॉडल आपका ट्रेनिंग डेटा पे तो बहुत ही अच्छे रिजल्ट्स देता है, बट जब टेस्ट डेटा की बात आती है तो वो अच्छे रिजल्ट्स नहीं देता. इसको हम क्या कहेंगे? कैन एनीवन टेल मी? If you are getting, yeah, overfitting, yeah, Aditi, correct. Okay, alpha ki range, the ones who are asking, see, it's 1 is the best, and then you can decrease it somewhere closer to 0, but upper values can be 100, can be 10, 20, so there is nothing like that, but we should not give that high value. You try something between 1 to 10, but not above that, and if you have to go lesser, you can go up to 0.3, 0.5, like that, but not 0, definitely, because 0 is like you don't want to train your model. Okay, so that's how it is. Okay, so the problem with the OLS model is the overfitting. Okay, so to avoid the overfitting came these two models actually, the ridge and the lasso models, to avoid the overfitting that was happening with the OLS, because my purpose is not to get better train accuracy, rather a better टेस्ट एक्यूरेसी ऑल्सो, बिकॉज फ्यूचर उसी से पता लगेगा कि फ्यूचर में मॉडल कैसा बिहेव करेगा. ओके, तो दैट्स व्हाई वी वांट दैट, and to do that basically what we did was we used an approach known as regularization. Okay, so regularization is done, and then we got two models, ridge and lasso. So ultimately, to avoid the overfitting of the OLS models, we have to do regularization. So someone if asks you what is regularization, this is what you have to explain. So to remove the overfitting of the OLS models, we were doing the regularizations. What is regularization? We will talk about. But there are two kind of regularizations, ridge and lasso. And what they do is they actually take this cost function j of theta and they modify it. Okay, there is a modified cost function that they uses. Okay, because if you talk about this, the whole game is running by this formula. The whole process is dependent on this formula. Okay, how that happens, guys? See, ultimately आखिर कन्वर्जेंस चलता कैसे है, कन्वर्जेंस मॉडल काम कैसे करता है? I told you that this graph is RMSE curves graphs, because it's a root mean squared error. It's a squared error, so that's how it looks like, squared function. And I told you yesterday that initially I take any random value of slope. Okay, I get my cost function, but I'm not satisfied with that. So based on the learning rate, I took a jump towards the global minima. But the question is, what is this jump? किसी को इंटरव्यू में आप ये जंप को एक्सप्लेन कैसे करोगे, right? What do you mean by this jump? So the jump is it's iteration. But what is iteration? What's happening in this iteration? So what happens is this model actually at this particular point, it calculates the slope of this curve. Okay, so those of you who are from the mathematics background, they can understand that if given a curve at a particular point, if you have to get the slope, right? Yeah, step size, yeah, Tanya, correct. So if you have to get the slope at this particular point, you have to do what? Partial derivative. Okay, so ultimately there is a partial derivative of the function j with respect to theta. Okay, so I normally request the students to at least be good in calculus, partial derivatives, first order, second order derivatives and all. So guys, what happens here is the process the process of gradient descent, उसका नाम है gradient is descending. Okay, gradient दो पार्ट है उसके, gradient descending, gradient descend कर रहा है आपका, मतलब gradient क्या होता है, gradient is nothing but the derivative. किसी भी इक्वेशन का gradient है उसको हम पार्शियल डेरिवेटिव से रिप्रेजेंट करते हैं और वो आपको स्लोप देता है उस पॉइंट पे. और आप ग्रेडियंट डिसेंड मतलब डिसेंडिंग मींस पहले इस पॉइंट पे स्लोप निकाला, फिर इस पॉइंट पे स्लोप निकाला, फिर इस पॉइंट पे वो उधर चला गया, सॉरी, देन इस पॉइंट पे. तो अल्टीमेटली ये जो स्लोप निकालते निकालते आप देख रहे हो स्लोप इज डिसेंडिंग टुवर्ड्स द ग्लोबल मिनिमा. तो इट इज योर ग्रेडियंट or the slope is descending towards the global minima with the help of partial derivative function on the cost function with respect to theta. Okay, so if you have to calculate two thetas like theta 1 and theta 2, so first it will be with respect to theta 1, partial derivative of cost function with respect to theta 1, so that you can calculate theta 1, and then with respect to theta 2, where theta 1 and theta 2 are nothing but the coefficients or the slopes. Okay, so guys, be aware about this. Like ultimately, what is this curve, what is this slope, what is this partial derivatives, what's all happening. This is how you have to explain these in interviews. Okay. So ultimately, the better this convergence, I would say the lesser the errors my model have. But OLS में model used to overfit, and to avoid that problem came this ridge and lasso. So what they do is, this ridge and lasso, they change your cost function, because see, ultimately पीछे सारी जो कहानी है वो किसकी है, इस ग्राफ की. ओके, इस डेरिवेशन की, ये जो डेरिवेशन चल रहा है यहाँ पे, पार्शियल डेरिवेटिव. सो वी चेंज दिस. सो व्हाट वी डू इन रिज एंड लैसो, आरएमएसई तो रहता ही रहता है, हम अपना कॉस्ट फंक्शन और ऐड कर देते हैं, मतलब उसमें उस फॉर्मूले में कुछ और ऐड कर देते हैं. जैसे मान लो अभी तक आप कहते थे कि y इज इक्वल टू एक्स स्क्वायर मेरा एक ग्राफ है, ठीक है, और मैंने कहा अब इसमें एक और टर्म जोड़ देते हैं, मान लो x. तो अब आपकी इक्वेशन बदल गई, राइट. y इज इक्वल टू एक्स स्क्वायर ही आपको पहले कैलकुलेट करना था, अब एक्स स्क्वायर प्लस एक्स करना है. तो आपका इस फंक्शन का जो भी आउटपुट पहले आ रहा था अभी वो पूरा बदल जाएगा, बिकॉज दिस इज अ न्यू इक्वेशन. सो इसका कर्व भी बदल जाएगा. तो यहां पर भी वही होता है कि आरएमएससी के साथ हम कुछ एडिशनल चीज ऐड करते हैं. वो रिज में अलग होती है, लैसो में अलग होती है. रिज में इट इज नथिंग बट, यू कैन से अभी के लिए आप ये मान के चलो कि अगर थीटा आपका कोफिशिएंट है, इट इज थीटा स्क्वायर. ओके, दैट्स इट. सो व्हाट आई एम डूइंग इज, here I am just adding the theta square, which is my coefficients. Okay, I'll tell you the behind it. Similarly, if it is lasso, it is not theta square, rather it is only theta. That's it, only theta, not theta square. Okay, now what will happen here? So for that, one second. So see guys, now what I was telling you yesterday, I was telling you, now this curve which I am plotting is of your target that you want to predict. For example, sales with respect to the marketing cost. You can have this as a straight line, I was telling you, in linear regression, and it could have been this straight line. If this is line 1 and this is line 2, out of this, and this, if this is line 3, which of this is having the highest slope, guys? 1, 2 or 3? Maximum slope? Okay, very good. So definitely this line is having maximum slope, right? But now the point is, the feature which is having higher value of slope ultimately will be taking more importance while predicting anything, okay? Because उसका slope बाकी slope से ज़्यादा है. So it will be dominating the other features. And that's where the problem arises of overfitting. You don't want a particular feature to, yeah, this one, Gulzar, this one, the more steeper, this one having the highest slope, okay? Okay, so now you understand that if there are 10 features and if there are 2-3 features which are having higher slope, very high slope comparative to others, they will dominate the thing and they may overfit the entire process. Now what ridge and lasso says is कि जितने भी slopes हैं उनको near to zero कर दो. So the process of regularization actually works towards minimizing the slopes and bringing them near to zero. तो अगर आपके 50 features हैं, सबके slopes को minimize या regularize कर दिया जाएगा, okay, to come near to zero, but वो zero नहीं होगा, but they will be reduced so that one particular feature is not heavily dominating the entire decision process, okay? So उससे हमें सीधा ये पता लगता है कि अगर मुझे स्लोप को रिड्यूस करना है तो जिस चीज को रिड्यूस करना है वो क्या होती है, कॉस्ट फंक्शन. तो उस चीज को कॉस्ट फंक्शन में ऐड कर दो, क्योंकि ग्रेडियंट डिसेंट उसी का तो ध्यान रखता है कि कॉस्ट फंक्शन को मिनिमाइज करना है. तो अगर मैंने स्लोप्स को कॉस्ट फंक्शन में ऐड कर दिया, स्लोप की वैल्यूज को, तो मेरी प्रोसेस उसको रिड्यूस करने की ट्राई करेगी. तो इसीलिए कॉस्ट फंक्शंस में स्लोप की वैल्यू ऐड कर दी गई और ये मॉडिफाइड कॉस्ट फंक्शन आपका नया बना, RMSE plus theta square or RMSE plus theta, whether it's ridge or lasso, so that if the thetas, those thetas which are very high, your model, the gradient descent process, will automatically take care of it. One second. Okay, yeah, so moving ahead. So now this is the entire intuition, the mathematical intuition or the reason behind going with ridge or lasso, and they penalizes the higher slope. When I say penalizes, they put some penalty on these higher slopes by adding them into this place, which is like my cost function. But since there is regularization happening and I'm saying penalty is being implied on higher slopes, those slopes which are higher, they will be brought near to zero. मतलब सबको जीरो के नियर लाएंगे, लेकिन जो हायर स्लोप्स हैं डेफिनेटली दे विल आल्सो कम नियर टू जीरो. सो वी वांट to put a regularization strength parameter known as lambda with both of these. So it's either lambda of theta square or lambda of theta. Means मैं कितनी ज्यादा पेनल्टी मारना चाहता हूं अपने मॉडल पे. The impact of this penalty is decided by me. So this is another hyperparameter other than max iteration and learning rate. We have the regularization strength or lambda parameter. Some people say instead of lambda they represent it by alpha, but don't do that because alpha is for learning rate. So that's why I prefer saying it lambda. Some people will say alpha also, but don't get confused. So it's lambda parameter, okay guys, which is actually the regularization parameter. Somewhere you will see it represented by C parameter. C as again the regularization parameter or the regularization strength. Okay, one second. So these are some of the important hyperparameters you need to be aware about. Okay. So let me tell you certain formulae before we jump into this. One second, guys. Okay. I have actually opened a few links to explain you जो भी हमने अभी तक discuss किया है, so that you can understand it better. This is what we were talking about, right? This कई बार इंटरव्यू में आपको ये कर्व दिखा दिया जाता है और आपको 4 ऑप्शन दे दिए जाते हैं कि किस चीज का कर्व है. मतलब जब आपको MCQs वगैरह भी सॉल्व करने होते हैं ऑनलाइन हैकर रैंक हैकर पे, तो you should be aware that this is the curve not for the prediction of target variable. Okay, this is not for prediction of target variable, this is for cost function. Okay, remember the difference. And here this is the starting point. Your model can start from here also, guys. Okay, there is no hard and bound rule. Your model can start and jump like this. It's just some random place your model needs to start at. अगर वो यहाँ से स्टार्ट होता है तो उसके स्लोप्स जो होते हैं वो they go in this from left to right. यहाँ से स्टार्ट होता है तो slopes are in the right to left directions. So model automatically understand this. This is the intelligence of partial derivative automatically, how it handles this. But remember, it's not that model should always start from the left side of the curve. It can start from the right side of the curve also. And this iteration width is dependent on the learning rate. And this is what the convergence is. This is what I was telling you, that your hypothesis, like in any machine learning model, you first build a hypothesis. So the hypothesis here is the prediction of the target variable with the help of a bias and a slope like theta naught and theta 1, where I have to predict theta naught and theta 1, that's it. For that I have the cost function, which is j of theta, where theta is nothing but theta naught, theta 1, theta 2, like that. And this formula is nothing but the formula for RMSE. Okay, this formula is nothing but formula for root mean squared error. But यहाँ पर आप देखोगे root गायब हो गया है, कोई problem नहीं है. Minimization problems में root does not play that important role, because अगर मैं कहता हूँ कि किसी की root value small हो रही है या actual value small हो रही है, एक ही बात है. पर्पस है स्मॉल करना है, मुझे उस वैल्यू को रिड्यूस करना है, तो रूट आप हटा सकते हो. ओके, बट द गोल फॉर दिस एंटायर प्रोसेस इज द मिनिमाइजेशन ऑफ कॉस्ट फंक्शन, विच इज j ऑफ थीटा नॉट एंड थीटा 1. ओके, सो दिस इज जस्ट टू एक्सप्लेन यू, जो भी हमने अभी तक बात की थी वही यहाँ हो रहा है. यही आपका ग्रेडियंट डिसेंट का एल्गोरिथम है. ओके, it's doing some partial derivatives. Okay, but yeah, that was just to tell you this. See, learning rate you set once for the model. Okay, so from your side you set the learning rate for the model, and ideally it uses the same learning rate during the iterations. It may so happen that a model identifies that it has already converged, so it will stop the iteration, but you don't set multiple values of learning rate. Graphically sometimes it may look different, but don't go by that. Learning rate you only set to be one constant learning rate, and your model uses that. Okay, but अगर आपने iteration बोला है 1000 iteration, तो जरूरी नहीं है कि मॉडल 1000 iteration लेगा. हो सकता है मॉडल 100 iteration के बाद रुक जाए, बिकॉज वो अपना ग्लोबल मिनिमा या लोकल मिनिमा तक रीच हो चुका है और फर्दर एरर रिड्यूस नहीं कर पा रहा है वो. तो रिमेंबर दिस, इट इज नॉट कि आपने 1 लाख का आइटरेशन रेट दिया है तो मॉडल 1 लाख बार आइटरेट करेगा, ऐसा नहीं होता. बट लर्निंग रेट आप एक ही बार सेट करते हो, इट इज टू बी कांस्टेंट अक्रॉस whether it's neural networks, whether it's machine learning, everywhere. Okay. Okay, guys. Now, if you see this, here I just want to tell you the formulae. So ridge regression performs L2 regularization, as I told you yesterday. Now, what do you mean by L2? Sometime in interview they ask you, ये L2 का मतलब क्या है? So this L2, guys, I will explain you. For that, you should know vector algebra. I'll explain you. But there is a reason behind saying this is L2 and this is L1. So this is known as L2 regularization. This is known as L1 regularization. The answer to that lies in this thing. So if you see the minimization of an objective function. So ridge regression का objective क्या है? Minimize करना है cost function को. वो cost function क्या है? जो आपका ओरिजिनल आरएमएससी था, मतलब जो लीनियर रिग्रेशन या ओएलएस, जो लीस्ट स्क्वायर ऑब्जेक्टिव फंक्शन होता है आपका, लीस्ट स्क्वायर का ऑब्जेक्टिव फंक्शन होता है, वो तो है ही है, प्लस जो है लैम्डा टाइम्स या अल्फा टाइम्स, ये लर्निंग रेट नहीं है, ओके, ये रेगुलराइजेशन स्ट्रेंथ है, इसलिए मैं कह रहा हूं लैम्डा टाइम्स ऑफ sum of square of coefficients. So guys, this sum of square of coefficients actually in the field of vector algebra, this is known as L2 form. And in the field of vector algebra, L1 form is this thing, the absolute value of coefficients. So ये जो formula है, actually ये जो additional part हमने add किया है, इसी को हम L2 या L1 formulas कहते हैं, इसलिए इनका नाम L2 या L1 regularization रखा गया है. Okay. And if you see, anything that you add as part of your cost function is a penalty. Okay. So that's why we are saying we are adding a penalty. So the penalty here is theta square. I was telling you, right? The square of the magnitude, theta square. But here it was only magnitude, the absolute value of the magnitude, which is theta. Okay. So these are what the formulas are. Now, let me show you that here programmatically. I hope all of you are aware about this markdown thing. So you can convert anything in markdown, which you don't want to execute. And that is what a theoretical things you want to add some concepts in your notebook, you can make it a markdown. Okay. Oh, okay, okay. So I'll share all these things. So today, before the class, I'll share all these things. 1 second. Okay. I will show you. but remember, this is the penalty, the model penalty, the regularization penalty, whatever you want to say. Max iteration, which is another important thing. Okay. And random state. Random state as in what? Set.seed, right? You do set.seed. So that's where the random state comes into picture. So these are the three most important hyperparameter. Further, there is this cyclic selection, which is not that important, but I will tell you later. But to understand ridge and lasso, आपको ये दो parameters पता होने चाहिए, alpha and max iteration and random state. These three parameters. So let me just start with this. So I'm explaining you the formulae first, how these formulae are.
So,
Yeah.
sir, can you show that cost graph once again?
Which cost graph?
सर जो आपने अभी गूगल किया था.
एक मिनट. So अभी मैं आप लोगों को सिर्फ फॉर्मूले बता रहा हूं, तो remember I'm not putting any values here inside these, but when we implement the actual models we have to set all the hyperparameters. Okay, remember this. Okay, so coming into the ridge regression. Okay, so what happens is, this is what the actual formula that model uses, and let's try to understand this formula with respect to the formula that we saw just now. Okay, so let me open the notepad. Okay, so guys, first of all, if you have to understand these formulas, like in interview, you have to explain these formulae. So how it is working is, first of all, this part is nothing but, first of all, this is your error, actual minus predicted or predicted minus actual, and then you take the square of the error, so that becomes a squared error. Okay, so that is the first part. Just leave this. So that is the squared error. But this part, the second part of the cost function, is the new part, which is alpha. Here is alpha or alpha, whatever you say. The regularization is strength. Then this thing is W, right? What is W? W is the coefficient or the weight or the slope. Some people say it weight, slope, coefficient, whatever. And then square of the weight. Okay, so that's the square of the weight. And if you see here, square of the coefficient, it's also the same thing. Square of the weight or square of the coefficient, same thing, one and the same thing. But if you have more than one weight or more than one feature, it will become sum of the square of coefficients. Okay, sum of the square of coefficients. So you have to just say W1 plus W2 W3 like that. So it's one and the same thing. Sum only comes into the picture if you have more than one variables. So it will be something like this. W1, W2. Okay. you remove this if it is of any confusion. ये underscore 2 बस इसलिए लगा रखा है because वो L2 समझाने के लिए है. तो ये आपके weights के squared का sum है, sum of the square of weights. So remember this. How these formulas are built, what these formulas are. But now the question is, ये जो double symbol है, for example, what do you say, pipe operator, double pipe operator here, double pipe operator here, इसका क्या मतलब है? Do any one of you know this? Guys, anyone know this? Those specifically from mathematical background. If W is a vector, what does this represents? Double W. It's not or, okay? Absolute value, positive value. Not exactly, guys. See, please study vector algebra. Okay, please study vector algebra. It will come. I don't know how you did support vector machine without vector algebra, because support vector machine internally uses the vector algebra. This thing, guys, is known as norm of a vector. Okay, if you have seen the cost function for a support vector machine, the cost function for SVM also uses this thing. Okay, if W is a vector, okay, if W is a vector, then this represents the norm of a vector. Okay, so W, if W is a vector, this represents the norm of a vector in the field of vector algebra or vector mathematics. So इसीलिए सपोर्ट वेक्टर मशीन में हम जो वेक्टर की बात करते हैं वो क्या होते हैं? They are, I'm not going into that, but there is the vector algebra. Okay, in support vector machines, Nitika, what is your question? And Gulzar, what is your question?
So what's the meaning of norm? What does it stand for?
Yeah, I'm coming into that. अभी मैंने खत्म कर किया है.
Okay.
अभी तो I have just started it, right? Okay. Yeah. So that's what I'm saying. Support vector machine is based on the vector mathematics or vector algebra. Okay. So what happens is, if W is a vector, then this represents the norm of a vector. Okay. Now, what is the norm of a vector? उसको समझने से पहले आपको पता होना चाहिए what is W. I'm saying W is a vector. Okay. So W is a weight vector. Weight vector as in W1, W2, W3. If you're not getting this much mathematics, guys, you can ignore it. Those who can understand it's fine. Rest can read it. So if you have a model that wants to predict 4 features, F1, F2, F3, F4. So any model, किसी भी मॉडल का काम क्या होता है? सिर्फ ये वेट्स निकालना. For the input features F1, F2, F3, F4, what are the specific weights? W1, W2, W3, W4, right? Correct? So तभी तो इक्वेशन बनती है. इस मॉडल की इक्वेशन क्या होगी? कोई मुझे पिंग करेगा? Guys, I want you to ping me. If y is equal to mx plus c is the form of a linear equation, and if these are my features and these are my vectors, please ping me this equation for y. Guys, I'm waiting. What will be the equation? Very good, very good. Thanks a lot. Okay. This F1, X1, F2, X2 is not correct. W1, W2, W3. Okay, correct. Yeah. Perfect. So the point is, guys, these equations that you are pinging me, these are the linear form of an equation. Okay, these are the linear form of the equation. Same equations can be converted into the matrix form. Okay, same equations can be converted into the matrix form. So when we convert our linear equations into matrix form, so you get actually two matrix. If you look at this, one metric for the weights or the slopes, and one metric for the feature values, and ultimately you multiply those two vectors or matrix. So किसी भी linear equation form, किसी भी को तो नहीं, most of the linear equations, they can be converted into the matrix form. So you can go today and study the matrix form for the linear regression, and you will see something like X transpose and all those things. I'm not going into that right now. But for that you should know matrix algebra. Okay, so you have to read matrix algebra for that. But I'm just asking you, if I'm talking about matrix algebra, okay, can anyone tell me what is the determinant of a matrix? Or at least do you guys know what is the what is determinant of a matrix, or how to calculate determinant of a matrix? Given a matrix, can you calculate the determinant of a matrix? Very good. Can you calculate transpose of a matrix, covariance of a matrix? Very good. I think all of these you done PCA में आप लोगों ने किया होगा, क्योंकि PCA cannot be done without the matrix algebra. नहीं किया? Okay. So then how did you calculate the covariance matrix? Okay. So PCA में the entire logic is to calculate the covariance metric, and then only you can calculate everything. No, mathematics no one will teach you guys. You have to study. No one is going to teach you, but yeah, I give the inputs during my classes so that you can study. So study the vector algebra, okay? Study the matrix algebra, okay? So there is these things: vector algebra, matrix algebra, and the most important is the calculus and the linear algebra. So you should be aware about these things, okay? Linear algebra, calculus, and then the vector algebra and matrix algebra. These are almost similar, vector and matrix, but with some difference. So be aware about this: how to calculate determinant of a matrix and all, how to calculate the transpose of a matrix, okay, or all these things, or even the inverse of a metric. So you have to study maths, guys. No, that's good. That's perfect. That's what the ask of the class is. But this is what my way of teaching is. Everyone is different. Okay. So but it's you who needs to study, guys. Please, huh? So matrix algebra जब भी पढ़ो, determinant of a matrix, transpose of a matrix, inverse of a matrix, you have to be aware about it, because तभी आप एक linear form को matrix form में convert कर पाओगे, नहीं तो वो आपको हवा ही नहीं लगेगी उसकी कि आखिर ये linear form को matrix form में कैसे convert किया गया है, जब तक आपको matrix algebra नहीं पता होगा, क्योंकि उसमें transpose, inverse, determinant ये सब चीजों की बात होगी. ओके, तो अभी हम अपने आप को फिर linear form तक ही restrict रखेंगे. ओके, तो अभी हम अपने आप को linear form तक ही restrict रखेंगे, हम matrix form की बात नहीं कर रहे. Study it, we will talk about it. But what I am talking here is norm of a vector, okay? So I am saying you guys that if y is equal to wx plus c, where w is the weight or the slope, then I can create a vector of w. I can create a vector of the input features, and I can simply do matrix multiplication. So this will become a matrix equation, okay, which is a different thing. Okay, guys, please hold your questions for some time. Let me first complete this. Okay, so now what I'm saying you is that w vector is nothing but जितने भी वेट्स हैं आपके, अगर उनको आप एक लिस्ट में डाल देते हो गाइस, या एक वेक्टर में डाल देते हो, वो आपका एक वेक्टर बन जाता है। बस आपने आर में भी वेक्टर्स बनाए होंगे, अगर आर होगा आपके अगर सब्जेक्ट में, तो इट्स दैट सिंपल। ओके, सो अल्टीमेटली आप अगर किसी मॉडल ने आपको 4 स्लोप की वैल्यूज प्रिंट की, तो वो 4 स्लोप की वैल्यू आप एक लिस्ट या वेक्टर में डाल दो, वो आपका एक वेट वेक्टर बन गया। ठीक है, सिमिलरली मैं एक फीचर वेक्टर बना सकता हूँ, बट फीचर वेक्टर की वैल्यूज अलग तरह से रिप्रेजेंट की जाती हैं। तो अगर गाइस ये मेरा वेट वेक्टर है और मुझे इसका नॉर्म निकालना है, norm of this vector here, this is not feature vector, rather the weight vector. So the formula for that is this. See this. Yeah. So this is I'm pinging you. For those who are interested in vector mathematics, they can study here. So guys, if you simply look at it, this is some point in the graph. Okay. Normally when you talk about points like x1, x2, they are your coordinates, right? So यहाँ पर अगर मैं कहता हूँ कि मेरे पास दो वैल्यूज है 1,2, तो मेरे पास x की वैल्यू है और y की वैल्यू है, मतलब x की वैल्यू ये 1 है और y की वैल्यू 2 है, राइट? एनी पॉइंट इन अ 2-dimensional ग्राफ कैन बी रिप्रेजेंटेड एज अ वेक्टर if you draw a line from origin. Okay, I'm just teaching some maths for those who are not aware. From origin, if you draw a straight line towards the point, but this line should have a direction. So if you see this arrow is very important. Okay, so if you see this arrow, so this is what a vector is. So here your u के ऊपर ये जो arrow लगी है, this means this is a vector. So if you see, this is u vector 3,4, this is a u vector. Okay, but what is the magnitude of this vector is actually nothing but the norm of a vector. So norm of a vector means this is known as magnitude of the vector, the length of that vector. What is the length or the magnitude of that vector, which is given by something like Euclidean distance you did, right? Pythagoras theorem, which is u1 ka square plus u2 ka square, where u1 u2 means 3 square plus 4 square. Okay, hope this is clear, guys. Now what is a vector? What is the norm of a vector? datascience.com. You're asking this notebook? I'll share all this. Okay, today I'll share this.
जो टैब है इसमें
Yes.
फिफ्थ फ्रॉम द लेफ्ट,
आपकी आवाज नहीं आ रही है क्लियर।
जो रिग्रेशन में जो आपका datascience.com वाली जो टैब है आपकी इसमें।
ओके, वो मैंने ऊपर ही पिंग कर दिया है, बट मैं दोबारा पिंग कर दूंगा एक बार। ओके, अच्छा निष्ठा, नो norm is not the resultant of two vectors. No, norm is for one vector. So see, this is one vector, and that vector has coordinates 3 and 4 are the coordinates. So this is u1 is like 3 and u2 is like 4, so 3 square plus 4 square. So it's not u1 vector or u2 vector. No, this is the first coordinate of u, this is the second coordinate of u. Okay, Nishtha, is it clear? Norm is for one single vector, not two vectors. It is the magnitude of a vector. क्या नितिका? So यहाँ अगर आप ग्राफ ये देखोगे, इसमें ये ब्लैक लाइन एक ही तो वेक्टर है आपका, ये जो u1 u2 है वो उसके x1 x2 कोऑर्डिनेट्स हैं, प्रोजेक्शंस ऑन द x एक्सिस एंड y एक्सिस। किसी भी वेक्टर को आप x एक्सिस और y एक्सिस पे प्रोजेक्ट कर सकते हो।
सर जैसे u वेक्टर है, इसमें हमारी इसके कोऑर्डिनेट्स हैं 3 and 4, x and y कोऑर्डिनेट्स। सर n डायमेंशनल होगा 3 और 4 डायमेंशंस में, तो उसमें इसमें तो हम पाइथागोरस लगा लेंगे 2 डायमेंशनल में, बट
सब में आपको
n
got
dimensions
it.
हो गए।
हाँ हाँ, आपको कुछ नहीं करना, u1 स्क्वायर प्लस u2 स्क्वायर प्लस u3 स्क्वायर ऐसे चलते चले जाओ बस। ये देखो,
और पाइथागोरस से ही हो जाएगा मैग्नीट्यूड।
हाँ मतलब अब पाइथागोरस हम लोग हमेशा से 2 डायमेंशन में ही पढ़ते आए हैं, इसलिए हम वही लिमिट रखते हैं अपने आप को, बट इट्स फाइन।
Yes.
तो 2 डायमेंशन में हम उसको पाइथागोरस थ्योरम कह सकते हैं, बट या इन हायर डायमेंशंस यू शुड नॉट say it's Pythagoras, but formula is still same.
So
Okay.
basically the square of all coordinates and their square root.
Correct. Okay. Okay, guys. So now since you are aware about this vector and norm vector, going back to this, so if you have a weight vector, means if you have say 4 weights, what should be the point here? It will be, the equation here will be this plus this square. अब अभी मैं 2 ही रख रहा हूँ, leave it. So this is how it will be represented if it is 2 vectors, for example, instead of 4. So this is how the norm of the vector will look like for 2 vectors. This is the norm of the vectors. So if I copy this, square root भी लगाना है, square root, right? Let me copy this norm of a vector, and now let me try to place it here. Okay, let me try to place it here. So it was telling you what? The square of the norm of a vector, right? If this is a vector and this is the norm of a vector, let me place this formula here, and the square outside. So a square will cancel the square root, right? Square will cancel the square root, right? You will get what? W1 square plus W2 square, and read this, sum of square of coefficients. So you reach to this, guys. This is the derivation. ये derivation समझ आई आपको formula की? How I derived it? Okay. So this is the final derivation of the model equation. What I did. So I just took it value from here, and since there was a square over there, it cancelled it out, and we get the final equation. If it's confusing, I'm putting it here. So this is what we derived. Okay, and this is in line with this. तो यहाँ पर W1 और W2 रहेंगे, तो इसको हम W कर देते हैं, so that आप confused ना हो. तो this is weight vector, norm of a weight vector, उसका स्क्वायर. तो ये हमारे पास फाइनल इक्वेशन आ जाती है. तो अल्टीमेटली हमको इसी को मिनिमाइज करना है. So we talked a bit about what is a vector, what is the part of vector algebra, norm of a vector, and you can represent a linear form into a matrix form as well, specifically in support vector machine. We do that. Okay. 1 second. So this is the ultimate mathematics behind it. No, nothing more left to talk about in the maths. Let's see the formula for lasso before we implement it. 1 second. Where is the formula for lasso? So this was the formula for ridge, guys. Now let me get the formula from here for lasso. Now, if you look at this, the linear model, which is trained with L1 prior as regularization. So that's the lasso. The optimization function or the objective function here is this. So let me put it parallel to this. Sorry. Okay. Just a moment. Okay. I'm just pinging you guys this notebook, the theoretical context. ओके, रिच को L2 रेगुलराइजेशन क्यों कहते हैं? बिकॉज नॉर्म ऑफ अ वेक्टर जो हम निकाल रहे हैं, मैग्नीट्यूड ऑफ अ वेक्टर, एक्चुअली दैट इज नोन एज this thing, norm of a vector. Guys, norm of a vector is also known as L2 form for a vector of a vector. So that's why. तो किसी भी वेक्टर की अगर आपसे L2 फॉर्म निकालने को बोली जाती है तो उसको हम नॉर्म कहते हैं, और अगर L1 फॉर्म निकालने को बोली जाती है तो वो मैं अभी बताऊंगा, तो वो इसीलिए हम उसको L2 या L1 कहते हैं कि आखिर हम फॉर्मूला क्या इंप्लीमेंट कर रहे हैं या पेनल्टी फॉर्मूला क्या है हमारा। ओके, तो अब अगर आप यहाँ देखेंगे इस फॉर्मूले को समझने के लिए पहले हम वापस इधर आते हैं। या ये मैंने पिंग कर दिया था, मैं दोबारा एक बार पिंग करता हूँ। या नोटपैड प्लस प्लस यूज किया करो गाइस। नोटपैड प्लस प्लस इज फार बेटर देन नोटपैड। We don't have time to talk about these things, but as a programmer you will find it far better. नोटपैड में आप टैब्स नहीं बना सकते, आपको अलग अलग लैंग्वेज के सिंटैक्सेस नहीं दिखाता है, वो अलग कलरिंग में एंड ऑल. So I never prefer this notepad. Use WordPad or Notepad plus plus. Okay. If you see, you can split the screens, plus you have different languages. So it supports different language syntaxes, SQL and all, and it tells you immediately if there is any error in that. So it's a proper, even a compiler. So it's good. You cannot run the code here, but you can get the syntaxes and all those things. Okay. Okay. Going back to this. तो अगर आप लोग यहाँ देखेंगे, लासो रिग्रेशन की जब हम बात करते हैं, हम कहते हैं कि फिर से हमें वही करना है कि स्लोप्स को, लासो रिग्रेशन भी एक रेगुलराइजेशन है, L1 रेगुलराइजेशन, बिकॉज वो वेक्टर अलजेब्रा या वेक्टर का L1 रिप्रेजेंटेशन को यूज करता है पेनल्टी की तरह, इसीलिए। और ये भी आपके मैग्नीट्यूड्स को पैनलाइज करता है, हायर स्लोप्स को पैनलाइज करता है और नियर टू जीरो लाता है। बट द डिफरेंस बिटवीन रिज एंड लासो इज कि रिज अगर आपके स्लोप की कुछ भी वैल्यू है उनको नियर टू जीरो ले आएगा, लेकिन रिज कभी भी जीरो नहीं करेगा किसी भी स्लोप को। रिज विल नेवर मेक एनी स्लोप जीरो, बट लासो विल सी दैट अगर कोई पैरामीटर ऐसा है, कोई फीचर ऐसा है जो बिल्कुल काम का नहीं है, तो वो उस फीचर के कॉरेस्पॉन्डिंग जो स्लोप है उसको जीरो ही कर देगा, मतलब फीचर को ड्रॉप ही कर देगा। तो एक तरह से लासो रिग्रेशन आप फीचर सिलेक्शन के लिए भी यूज कर सकते हो। इट ड्रॉप्स द अननेसेसरी फीचर्स बाय मार्किंग देयर स्लोप एज जीरो, बट रिज विल नेवर डू दैट. Ridge will bring it near to 0, 0.1, 0.2, 0.3 like that, but will never make it 0. That's the biggest difference. So two difference between ridge and lasso is, one is L2 form, another is L1 form. So you have to explain the formula. And second difference is lasso even acts like a feature selection where it drops some of the features by making their slope as 0. Okay. Now the absolute, guys, the absolute value of the magnitude, okay, is the lasso regression. What do you mean by that? Let me copy this. Okay. So here if you have a weight vector W, okay, if you have a weight vector W, you don't use any L2 form. The L1 form will simply say if W is equal to a weight vector W1, W2, W3, W4, then the L1 form of this, which is represented again by this and _1. ये _1 यहाँ पर क्यों है? क्योंकि गाइज ये एक्चुअली _1 नहीं होता, ये ऐसा होता है, ये नीचे यहाँ पे सबस्क्रिप्ट या सुपरस्क्रिप्ट आपने सुना होगा ना, ये नीचे 1 लिखा होता है. आई टेल स्प्लिट करने के लिए आपको बस किसी भी इसको ड्रैग करना है और इसको ड्रॉप करो, वो पूछ लेगा आपसे मूव टू अदर व्यू, ठीक, और क्लोन वट एवर यू वांट. ओके, तो ये ओके, तो ये जो _1 है ये बता रहा है कि इस वेट वेक्टर का जो नॉर्म निकाला उस नॉर्म का L1 फॉर्म. ओके, सो yeah, it's subscript. So the norm of a vector is of two types, the L2 and L1. The L2 formula we just saw on the left hand side, and now we are looking at the L1 formula. L1 formula is nothing but W1 plus W2 plus W3 plus W4, that's it, like that, but with their absolute values. Okay guys, their absolute values, मतलब अगर कोई value negative है, we will not take the negative sign, it is absolute values. तो ये जो सिंगल पाइप होता है, that मतलब दोनों साइड पे, that is for absolute values, right? तो अगर इसके अंदर -2 है तो it will become 2 because I'm talking about absolute value. Okay, because I may have coordinates. If I talk about a graph, or rather if I talk about this kind of a graph, I can have a point here, right? For that the vector will be in this direction, right? But for this the values will be x is say 1 but y is -1, right? So the L1 form for this will be 1 plus absolute value of -1. Okay, so which is equal to 2. So this is the answer. This is the L1 form. But इसी की अगर L2 फॉर्म निकालनी हो तो L2 फॉर्म तो इस केस में वैसे सेम ही रहेगी, which is 1 का स्क्वायर plus -1 का स्क्वायर, which is again giving you the same value only, -1 का स्क्वायर. Okay, but you have this thing, right? No, it can't be same, but you will do this thing, so it will be root of 2. So this will be the value for the L2 form. Okay, so remember this. In interview कई बार object, मतलब जो core data science companies होती हैं, they give you some online exam in which they may ask you to calculate these values. They give you the options, 4 options. What will be the L1 value for this vector? What will be the L2 value for this vector? So remember this. नहीं, अगर गाइज आपको अभी भी फॉर्मूले में डाउट्स हैं, प्लीज refer the links that I have shared. Not this. Refer these links, okay? So it may take time. Why not square root, guys? I am not getting it. I may be missing something. Please correct me. Sum of squares, सिर्फ L2 तो. No. I'm not getting. Karan, am I doing any mistake? Please, guys, 1 second. Hello. Okay. Karan, I got it. Where you got confused. Wo, that was the derivation actually, where we cancelled the square root with a square. Yeah. Yeah. I got it. Where you were confused. Okay. So I'm erasing this stuff. Okay. So guys, this was some bit about vector algebra. You can read about it more and how the functions are actually derived. Okay, this thing. देखो इंटरव्यू में क्या पूछा जाएगा गाइज वो किसी को नहीं पता. It all depends on that person who is sitting there. Plus it depends on the company also you go for. Okay. So till now we have talked about a lot, like the problem with OLS, what was the OLS, what was the cost function for OLS, what was the gradient descent process. Similarly, ये चीज जो मैं आपको अभी बताना चाह रहा था कि these are the linear algebra specific forms. This is the matrix form, the matrix equation to convert a model. So you can represent it like X transpose multiplied by X, and whatever matrix you get, the inverse of that matrix, xt y. Don't go into that, don't get confused, but yeah, any model can be represented like a matrix equation. Okay, coming back to this thing, the mathematical formula we have been talking about. OLS में हमारा ऑब्जेक्टिव फंक्शन क्या होता है? किसी भी मशीन लर्निंग में हमारा ऑब्जेक्टिव फंक्शन या ऑप्टिमाइजेशन फंक्शन हमें पता होना चाहिए. तो OLS में हमें पता है कि हमें एरर मिनिमाइज करना है. argmin तो पाइथन का एक कॉन्सेप्ट है. In Python we normally talk about argmin, but you can say minimum value for the error. इसने बस error term लिया है यहाँ पे, sum of all the errors, but you can talk about the RMSE also. Okay, but here if you see, while this guy is moving to ridge regression, what he's trying to tell you, for ridge regression you need to calculate. पहली बात तो आपके पास सारे कोफिशिएंट्स होंगे आपके, उन कोफिशिएंट्स का नॉर्म, लेकिन नॉर्म का भी L2 फॉर्म, L1 फॉर्म नहीं, L2 फॉर्म ऑफ अ. तो कई बार अगर इंटरव्यू में पूछे कोई आपसे कि गिवन अ वेक्टर, गिव मी द नॉर्म ऑफ अ वेक्टर, तो you should be very specific that whether he's talking about L2 or L1. But in general, when people say norm, they are talking about L2. So you have to ask whether you want me to give you the L2 formula or the L1, but the default people normally talk is L2. So here is the final formula, guys, where I'm trying to get the minimum value for what? My error, the error, RMSE, MSE, whatever, plus lambda times, lambda here is the regression regularization strength, and this is what we discussed, square. So this is ridge regression. Okay, so don't get confused, because here he is talking about the vector form, but that's fine. This is what I have explained you. Okay, so leave it further. Let me just check if there is any other important thing I need to tell you in this. Not this, not this, not this, not this. Cost functions. Okay, I think theoretically whatever we had to discuss we are done. We will take a break for 10 minutes, guys, and we will connect at, so we will connect at 11:45, and then we will start the hands-on. Before that, give me 2 minutes.
Sir,
One second. So guys, I have my GitHub account. Okay. So after the class, I always put the code on the GitHub. So you have to go to my GitHub account. I'm pinging you. So I'm not going to share you anything over email. Okay. What you need to do every day after the class, I will upload the code on my GitHub account. You have to get it from there. So there you can see multiple projects I have created or repositories. You have to go to this data science Python wala, not R wala or ye Flask or Python or big data. Go to this data science Python for you. Click on this. So here you already have all the code. Okay, I already have the entire code. But say I'm taking your classes, so I will still be putting the notebooks for you guys. You can still access all of these, but when you go to these notebooks, you can still go to other things, hackathon, Kaggle, data files, concepts, and everything. If you want PPTs and everything is there, but you go to notebooks, and there you see you want to see unsupervised like PCA and all, time series, Kaggle, and anything. And these are in general. These are for the classes. Okay. So, for example, Ridge and Lasso is already there. Okay. And similarly, others are already there. So every day after the class, I will take half an hour to upload the latest code, and after 30 minutes you can check it that whatever we discussed, your codes will be here. Okay. This is one of the important thing. For example, if you go to this Ridge and Lasso Python notebook, you can see that last it was uploaded 3 months back. Okay. But now if I do any code changes today, I will again upload it here. So you will see that it is uploaded like 1 hour back or 2 hour back. Or else I will put it like underscore PGA-07 so that you can even differentiate what was the older one and what was explained in this class. Okay. This is just a rule of thumb you remember. Those of you who are not aware about GitHubs, please read about it. This is how you work in the industry with GitHub. So for example, if you have to open any notebook here, say Ridge and Lasso hi, so click on this. It's just opening the notebook. The entire code base is here available, everything with the final output and everything. But those of you who are aware about how to download it on your desktops, it's good. Those who don't know this, what they need to do is click on this raw. Okay, click on this raw. Copy this entire content, because here you won't see the code, you would rather see some HTML and JSON. This, and so copy entire content, open a notepad ++, go here, paste that content, save that file as a .ipynb file. Okay, let me just save it. Okay, I'm saying demo.ipynb. Just save it like this. Don't save it as .py. Okay, don't save it .py. इसका नाम .ipynb होना चाहिए. Interactive Python notebook. Okay, ipynb. Let me save it on the desktop. So once it's saved, sorry, it became something else. ये भी आपको चेंज करना है. Make it all types. Okay, don't do it. Otherwise वो ये बन जाती है. .ipynb .txt बन जाती है, वो गड़बड़ हो जाता है. तो remove that. Select all types. Let me go to the desktop. Save it. Now it's done. 1 second. So I have this file. Okay, .ipynb. Now I can open this file in the Jupyter. So 1 second. Okay. So my Jupyter notebooks are actually here. So you can place it at a proper place. Okay, let me refresh this. So I have just placed it here. It came here. Okay, demo.ipynb. I'll open it. So it will open. Okay. So those of you who don't know how to use GitHub, this is the easiest way of doing it. Again telling you, 1 second. Come to my GitHub account, come to the notebook that you want, click on this raw, it will give you the raw code. This one, copy it, save it in a .ipynb file. It's on my desktop. I cannot open it from desktop. Means I can open it, but I have to unnecessarily do some additional stuff. So इसलिए better क्या है? I'll copy it and put it under the Jupyter folder, जहां से मेरे सारे नोटबुक खुलते हैं. तो मैंने उसको वहां डाल दिया. ठीक है, यहाँ पे डाल दिया और उसको यहाँ पे अपना होम पे, ये होम पेज जो जुपिटर का होता है, यहाँ गया, रिफ्रेश किया और रिफ्रेश करते ही वो नोटबुक यहाँ पे विजिबल हो गई. तो आप लोगों को ये पता होना चाहिए कि आप किस पाथ पे आपकी सारी नोटबुक्स बन रही हैं. ठीक है, उसी पाथ पे आपको वो वाली नोटबुक भी रखनी है. ओके, अगर आपको ये नहीं पता कि किस पाथ पे मेरी नोटबुक्स बनती हैं, लेट मी टेल यू, 1 सेकेंड. Yeah, Anam, I have a YouTube channel. I will share you, but that is not updated. I don't get time to update it. Okay, I will share that. See guys, this is C users admin. So this is the path where you are pointing by default. So you can put your notebooks there and access it. C में users में admin में. तो मैं भी कहाँ गया हूँ? ये देखोगे तो C में U को डाल दिया है. Okay. That way also, when you asked us to ping the equation. So Gulzar, the first one is correct, not the second one. Okay. You are saying F1, X1, F2, X2, X3, X3. That is not correct. Okay. The first one, W1, F1, W2, F2, W3, F3 is correct. Because X1, X2, X3 तो कुछ है ही नहीं ना यहाँ पे. हमारे फीचर्स का ही नाम है यहाँ पे F1, F2, F3. आई थिंक आपने वो कंफ्यूज हो गए होंगे. यहाँ X1, X2, X3 की जगह F1, F2, F3 है. ठीक है. ओके. So this was about it, guys. We'll take a break and connect after 10 minutes at 11:50, and we'll continue from there, the coding part. Someone was having a question. Rest guys, just take a break. Who was having the question? Nishtha, Nitika, I think someone out of you.
Yes, sir.
Yeah, tell me.
Sir, can you just open the graph of J cost?
Graph of which one?
Cost. Linear regression cost.
This one?
Yes, sir.
Tell me.
Sir, इसमें basically when we see the slope, so what do we call the slope as? These are the points where what exactly do we conclude of this line? हम इस line पे क्या कर सकते हैं? क्या कहें सर?
Okay.
जिस पे हम iteration करते हैं, what do we say?
नहीं, iteration, okay. आइट्रेशन हम स्लोप पे नहीं करते. हम पहले जो पॉइंट होता है हमारा, ये जो पहला पॉइंट है, हम इस पे पार्शियल डेरिवेटिव करते हैं इक्वेशन का. ठीक है. पार्शियल डेरिवेटिव करते हैं यूजिंग दैट पर्टिकुलर वैल्यू ऑफ. देखो ये क्या है, ये इक्वेशन, ये कर्व है राइट. और इस कर्व में मुझे अगर थीटा की वैल्यू मतलब एक्स एक्सिस की वैल्यू पता है, मैं वाई की वैल्यू निकाल सकता हूँ, राइट? तो गिवन द वैल्यू ऑफ एक्स, I need to calculate the value of y, and how I do that is, for y, I have a formula which is the cost function formula, and I have to put this value in that cost function formula, okay, to calculate the actual cost or the error, right? So I first do the partial derivative of this equation. I do the partial derivative of this equation, and whatever I get in using this, okay, that is my cost value. So ultimately मुझे cost function निकालना है, तो उसके लिए पहले मैं इस लाइन पे partial derivative करता हूँ और ये थीटा की वैल्यू उसमें डालता हूँ, so that I get my error. Okay, that is one thing. But then I see, no, I am not satisfied with this error. Okay, I have to decrease it. Then I select another slope, this, and then again calculate the error by putting this new theta or slope value in the cost function. Okay, but the process of moving from one slope to another, like you tried one slope in first iteration, you tried another slope in another iteration, so this is a jump. So during jump nothing is happening, it just at this step what is happening. So when I am at this step, I will do the partial derivative and I will do some calculations and I will get the error. And if I say no, I am not satisfied with this, I will select another value of m, and then I will calculate another value of cost function or the partial derivative of cost function. So changing from one value of m to another value of m, you are moving from one iteration to another. So that's why we are saying jump, but actually nothing is happening during that jump. The point is how long this jump should be is decided by two things. One is the learning rate, and second is whether it is normal gradient descent, whether it is batch gradient descent, or whether it is stochastic gradient descent, which I asked you guys to read. So what may happen is sometimes you may jump here, but the next iteration, the next slope value that you select, you may jump here, and you will now be calculating the formula, the cost function for this value, and then you say no, I am not satisfied with the value, though it is better than the previous, because if you say this will give you better result definitely, but if still not good, so you will take another jump. But because if your learning rate is bigger, learning rate आपको slope कर्व के एक साइड पे रखता है हमेशा, लेकिन बड़े या छोटे जंप डिसाइड लर्निंग रेट करता है, लेकिन ग्रेडियंट डिसेंट ये डिसाइड करता है, टाइप ऑफ ग्रेडियंट डिसेंट, कि आप एक ही साइड पे जंप करते रहोगे या कहीं आप रैंडम जंप्स मार रहे हो ऐसे इस तरह से, which is not good. तो stochastic gradient descent actually do this random jumpings, इसीलिए वो इतना सही नहीं होता, बट वो फास्टर होता है, तो इसलिए मैंने आपको पढ़ने को बोला था वो. तो ग्रेडियंट डिसेंट या बैच ग्रेडियंट डिसेंट एक ही साइड पे जंप करता रहता है, उसके पीछे पूरा रीजन है, वी डोंट हैव दैट टू डिस्कस, बट stochastic gradient descent takes jumps like this, वो कर्व के एक साइड दूसरी साइड, एक साइड दूसरी साइड, ऐसे भागते भागते फिर लोकल मिनिमा तक पहुंचता है. तो डेफिनेटली वो फास्टर है, बट इट्स नॉट दैट एक्यूरेट.
एक सर मिनी बैच ग्रेडियंट डिसेंट भी है.
करेक्ट, मिनी बैच ग्रेडियंट डिसेंट इज नथिंग बट, जो मैंने आपको बैच ग्रेडियंट डिसेंट बोला था, मैंने आपको बोला था तीन चीजें. ग्रेडियंट डिसेंट which is nothing but, okay, you can say batch gradient descent, then there is mini batch gradient descent, and then there is stochastic gradient descent, जो तीन मैंने बोले थे. तो मिनी बैच ग्रेडियंट डिसेंट भी बैच ग्रेडियंट डिसेंट की तरह ही होता है, बट द नंबर ऑफ रिकॉर्ड्स इट यूजेस टू डू द आइटरेशन इज लेसर. तो मतलब मिनी बैच ग्रेडियंट डिसेंट इज, देखो ग्रेडियंट डिसेंट सबसे स्लो है, मिनी बैच ग्रेडियंट डिसेंट इज फास्टर, स्टोचैस्टिक इज फास्टेस्ट, ओके, बट the accuracy keep dropping, okay, because of the randomness. Okay, mini batch gradient descent is not random, but it uses lesser data to converge. That's why it's faster. Okay, that's why the name is mini and batch. The batch size is lesser as compared to the batch gradient descent. That's why it's faster. But again, the accuracy is slightly different. Like normally, if you're getting 95, it will give you say 94, 93, like that. Okay.
Okay.
If you're more interested, I would say go through this thing, how the gradient descent actually works. I'm pinging you. So how the gradient descent actually work, how you do the minimization, what are the partial derivative process, and how, if you see here, somewhere it's showing you the random jumps, here it's showing you the normal one. Okay. So sometimes, yeah. In interviews, okay, in online interviews, this kind of questions comes. If you choose what to be very small, gradient descent will take small steps to reach the local minima. Uh, okay, like this. So, and if we choose what, so this is all about learning rates. Okay, so even a higher learning rate, okay, even a very high learning rate can also result in the randomness, and it may fail to converge. Okay, that's the problem because of very high learning rate. As I told you कि किसी को आपने बोला कि कल एग्जाम है और आज 10 बुक खत्म करनी है, तो वो बस पन्ने ही पलटता रह जाएगा. He will never be able to reach to the knowledge which he wanted to. तो वही सारी बातें हैं. But yeah, those of you who are interested, read it. और ये पॉजिटिव स्लोप्स नेगेटिव स्लोप्स क्या होते हैं, मतलब अगर आप इस साइड पे स्लोप निकालोगे तो यू आर गोइंग लेफ्ट टू राइट. Okay, and then if you are getting slope here, you are going from right to left. So which one is increasing slope, decreasing slope? Read about these things. Okay, positive slope, negative slope क्या होता है. So easy तरीका है उसको याद रखने का. Take this as like you are left to right, you are going from positive to negative, and here you are going from negative to positive. Guys देखो, मशीन लर्निंग या डेटा साइंस ऐसा कोई छोटा फील्ड नहीं है. देयर इज अ वेरी डिटेल्ड थिंग. लीनियर रिग्रेशन अपने आप में आप 1 महीने तक पढ़ सकते हो, इतना डिटेल्ड है. ओके, so go through it if you want study more. I have shared you the links. So now we will start at 12 o'clock, guys. I need some break. Okay, we'll start at 12 o'clock. Okay, guys, I'm back. So we'll start with this. 1 minute. Yeah. Okay. So now we will be starting with the hands-on of these models. So first of all, let me just show you what I have here. Okay. So I'm just running everything, running all the cells. It might take some time.
Excuse me, sir.
1 second. 1 second. Yeah, tell me.
Sir, I had few questions. So should I ask them now या फिर बाद में?
No, separately.
Okay, fine.
Okay. Okay, guys. So what we are doing is we are starting with the regional lasso. So first of all, let me just show you what I'm doing. आप लोगों को पता ही होगा इतना that how to read a file, right? So I have imported a pandas package, and from that I am using read CSV to read a file. So here the data I have is the insurance data, as in based on a person's age, his BMI, and certain other details. I am just calculating his insurance premium that he needs to pay. Okay. Uh, Plus there are other fields which is like his gender, the whether he's smoker or not, which area they live in. Okay. So all those fields are here. So definitely you can use this shape to just check the number of records and the number of columns, and just check all the columns which is there. So not going into that. Yeah. So null handling, definitely you guys must be doing it like this. The data frame name dot is null and dot sum. So it tells you 000. That means no nulls are present in either of the column. Okay. Then we have to do duplicate handling. Means my data should definitely not have any duplicates. So data frame dot duplicated. This is a function which tells you true or false. If any record is a duplicate record, I'll pass it on to the data frame and I'll get that okay, this particular record is a duplicate record. Okay. Where record number 581 is a duplicate record. But now to check which other record is also like the same, I can simply take one value of this, like charges is equal to this, and insurance data frame में filter लगा दिया मैंने कि insurance dot charges equals to this. So I get two records, like 195 is the original record and 581 is the duplicate record. तो अल्टीमेटली मुझे एक डुप्लीकेट रिकॉर्ड इसमें से ड्रॉप करना है, एक ही रिकॉर्ड रखना है, तो आई कैन यूज ड्रॉप डुप्लीकेट्स and that's it. So I have checked for the nulls, I have removed the duplicates. Finally I have my insurance data where I have age, gender, BMI and all those stuff. This gender columns and region column, I can definitely handle it in multiple ways. Either I can drop them if they are not needed, but if they are needed, based on my knowledge, I should do one hot encoding or label encoding. Okay, so I went ahead here, I did ordinal encoding, definitely, which is another kind of encoding. What happened? Import. So the point here is I did certain codings, which is like label encoding or the ordinal encoding or one-hot encoding. It is just to explain what different encodings are, but we are currently not talking about that. We can do any kind of encoding. There is some error which I can look later. I can use get dummies also. These are all encoding ways. So again, not going into that. The another important thing is ki, whenever you do any data handling, make sure at the end you also check for nulls, because sometimes I have seen that if you do scaling or you do some other kind of data pre-processing, some nulls gets introduced in the data, maybe because of some calculations and formulae. So once you check nulls in the starting and then you check at the end, before you do your train and test split, so that if you see in my data some nulls they got introduced. I'm not going into that like why they got introduced, but yeah, so I can definitely look into that data and remove it, but this is for your knowledge. Then I did certain splitting and all. I'm doing train test split like you guys have been doing it for long. Again, not going into that. Yeah, so from here our work starts, model building. Okay, so guys, which package you use for linear regression? Is it sklearn or it was stats model? Please ping me. sklearn. You didn't use this thing, the stats model. Okay, means it's an alternative. No, that's fine. It's not needed. I'm just telling you. Stats model was an older package. It's still used in some places, which was used for both statistics and modeling. So, but later on, the modeling part from this stats model package was moved, okay, into the sklearn. So sklearn का एक तरह से parent ही रहा था ये package, okay. So because this package was getting bigger and complex, because it was handling statistics also, so they preferred moving the modeling part to sklearn. But still, you can use OLS and specifically time series through stats model only. So normally when we talk about these two, like OLS models and the time series model, we go to stats model package. One second, guys. But sklearn is powerful enough. You don't really need to switch to stats model. Okay. Yeah. So so whenever we talk about the linear regression model, so this is what we do. Can anyone tell me इस step को करने का फायदा क्या है? What is this step known as? Guys, what is this step known as? Why you do this step? No, saving our classifier, but why you want to save your classifier? Yeah, Tanya, you gave the right answer here. So as to make the object, okay, it's the object of the class, okay. So what's happening here is this linear regression is a class, okay. Here I'm calling sort of a constructor on a class. This is the class constructor. Those who know Java, I'm sort of calling like a constructor on a class to create its object, okay. And an object, as I was talking yesterday, can be used to access the methods, right, of a class, methods or variables of a class in object-oriented programming. So that's why this object, the regression object, is used to call the fit method of the linear regression class, okay. So now before we go into the detail, let's see the actual code which is running behind the scene. Okay. Can anyone of you tell me where can I see the actual code which is written for linear regression? ये तो fit method है, लेकिन fit method internally क्या कर रहा है वो मुझे कैसे पता लगेगा? Guys, can anyone tell me where can I see the actual code which is there? No. Okay. Yeah, Karandeep, that's one of the way. Good, very good. But that is not detailed. That don't give me the detailed info, Karandeep. No. Guys, you heard about site packages? Are you aware about the site packages? Okay. Okay, good. Those who heard about it. See, guys, whenever you do pip install, all the packages that comes from the internet, they get saved on your local machine. Okay, and you should be aware like where they are getting saved. Okay, so we say import site package, site dot get site packages. This is giving me the path. तो कभी भी आप पिप इंस्टॉल करते हो तो आखिर जो फोल्डर या जिप फाइल्स इंटरनेट से डाउनलोड होती हैं वो कहाँ जाके स्टोर होती हैं आपके सिस्टम पे? एट दिस पाथ, सी प्रोग्राम डेटा एनाकोंडा लाइब्रेरी साइट पैकेजेस, ये सेकंड वाला पाथ उठाना. Copy this. Let's go to this path. Okay, I'm pinging you this. Please run this command, guys, and follow along. Just copy this one जहाँ पे site packages आ रहा हो. Now let's go to that path. So guys, please follow with me. Tanya, am I audible? Yeah. Okay. Guys, please go to this path. मैं क्या बोल रहा हूँ, बस ये जो कमांड पिंग किया वो रन कर दो. सेकंड वाला जो पाथ है जहां पर साइट पैकेजेस वाला दिख रहा है, ओके, इस पे हम जाएंगे और ये फोल्डर को अपना ओपन करेंगे लोकल मशीन पे. जिनका मैक है उनका थोड़ा अलग पाथ आ सकता है, बट मोर ओवर सेम. Yeah, run that, Gulzar. Yeah, run that command and then you get this path. Okay, and open this path in your Windows Explorer, which is this. Put it here. Few people can directly try to hit this path. It may be same, but not for all. And you will land somewhere at this path. This is the actual system which is running your Anaconda. If I delete any folder from here, it may corrupt the entire Anaconda. Okay. If you make any code change, any folder deletions, it may corrupt your system, or it may corrupt some specific functionality, not the entire Anaconda, but some specific functionalities. Guys, are you able to reach to this path? Perfect. Very good. Very good. So guys, now देखो आप इंटरनेट से जो भी पैकेज इंस्टॉल करते हो, दे आर पैकेजेस. तो साइट पैकेजेस मतलब ऐसा फोल्डर जहां सारे पैकेजेस पड़े हुए हैं. तो आपने जैसे sklearn की बात की, तो लेट्स सी sklearn, you can see here sklearn. So sklearn, you must have done pip install sklearn. So this is the folder. Pandas, see, you did pip install pandas, it is here. NumPy, it must be here. Okay. NLTK for natural language processing, NumPy, everything is here. Okay. So I am going inside this sklearn, guys. Go inside sklearn. Now here you can see the subfolders, feature extraction, feature selection, everything. Now let me show you it here. When you say import sklearn dot, anything that you say here, guys, these are the subfolders inside the sklearn folder. All of these, cluster, compose, covariance, these are subfolders. So you have been using what? Linear model, for example, right? So linear model must be a folder inside this parent folder. So let's go inside it. See, we have linear model. Go inside it. Then what you do? Then you import the actual class, right? Which is linear regression. So in linear regression, or maybe you do say ridge or lasso. So you can get the .py files there, ridge.py, linear regression.py. Or if the py files are not there, you will get some parent file inside which these are created as classes. So you may not see ridge.py, but there will be a class with the name of ridge. How to check that? Let's go back. Come here. What I am looking for is linear regression, right? So linear regression must be a code here. See, ridge is there, but I'm interested in linear regression. Logistic is there, linear is not there. So what I will do, there is this base file. Let me go inside this base file. See, guys, you can see a class is already there with the name of linear regression. Okay. What I'm saying is this linear regression is a class, right? That's what I was telling you. But how can you prove that? Go here. अगर कभी भी आपको वो एग्जैक्ट फाइल ना मिले तो हमेशा बेस फाइल को ओपन करो, बेस फाइल को, because base file is the parent of all the files here. Okay, you can open this base file also, it's fine, whichever you want. This base file can also be opened, but you won't see much of the details here. So if you see here, there is a class with the name of linear regression, which is the ordinary least squares, OLS. Okay, and even what Karan you were saying is also right. If I do question mark of the object, I can still see that info, but from where this info is coming? This info is actually coming from that file only. Okay, whatever you see here is actually being read from that file. So if by mistake you delete this file or corrupt these files, your linear regression model will stop working. Other models will work, but linear regression will not work. Okay, see all everything that you see here. Now you are having two functions in any model, .fit and .predict. So you see inside that class there is a fit method which is taking the x and the y of the training data, the features and the output. No sample weight by default, so that's fine. Sample weight I'm not giving. And then there must be a predict function. Okay. And this, can anyone tell me what is this, guys? In Python, double underscore init double underscore function is a special function. What is this known as? Guys, what this function is known as? Interview में पूछा जाता है. What is this function? Double underscore init double underscore is a special function in the field of Python. It is known as constructor. Like those who know Java, there is a default constructor, right? So this is a constructor equivalent of Java. So this is known as constructor. So whenever, guys, whenever you are calling this thing, one second. So guys, whenever you are calling this stuff, okay, whenever you are creating the object, this function is auto triggered. This function is auto triggered. You don't need to call this function explicitly. आप fit function को अलग से call करते हो, predict को अलग से call करते हो, right? But you never call this function. Why? Because this step it automatically calls the constructor. Okay, what is the constructor? Double underscore init double underscore. Okay, remember this. So this step is very important. Here you are creating an object of the class linear regression, and the default constructor is being called here. Yeah, Gulzar. Auto triggered means automatically called. Okay. जबकि ये fit function, predict function आपको खुद से call करने पड़ते हैं. Okay. So remember these things, guys, and this will help you to actually see what is happening inside the system. All these complex logics. Okay. What's actually the system is doing, like whenever it's running the things at the back end. Some models internally do the data scaling also. So you can check here like whether my model is doing the scaling or not. There are a lot of such stuff. How the data handling is happening. What is this parallel thing? Okay. So normalization and all. So be aware about these stuff, pre-compute and all. These are your hyperparameters. So if you want to see what is the impact of my hyperparameter, then you can check here. So अगर तुमने फिर से यहाँ पर आते हैं, जैसे hyperparameter एक मॉडल में 50 हो सकते हैं, लेकिन हमें सिर्फ 5 की जरूरत है. लेकिन अगर आप कल को इंटरेस्टेड हो तो आप देख सकते हो कि बाकी हाइपर पैरामीटर्स की वैल्यू का भी मेरे मॉडल पे क्या इम्पैक्ट होने वाला है. जैसे अगर नॉर्मलाइज की वैल्यू मैं दे दूं तो यहाँ से तो मैं वैल्यू ट्रू और फॉल्स दूंगा, लेकिन वो एक्चुअल में क्या करने वाला है, या और भी कोई अगर मेथड हो ऐसा. फॉर एग्जांपल अगर मैं प्री कंप्यूट ट्रू करता हूं तो वो क्या करने वाला है. तो प्री कंप्यूट इज रनिंग सम नम्पी एरे, एक एम्प्टी मैट्रिक्स बना रहा है वो नम्पी का, एंड डूइंग सम ऑपरेशन ऑन इट. ओके, but the point is you should be able to understand what's happening at the back end. Okay, similarly you can go to all the other models. Logistic perceptron is like neural network. SAG we were talking yesterday, right? Stochastic average gradient descent. So one second. So make sure guys you go through these, and if you land somewhere like this, go inside SAG, this folder, like this is SAG. If it does not contain anything, there is this underscore SAG. Go inside that, edit with Notepad++, and then yeah, you can actually look how the stochastic average gradient descent works. You can go through certain links also. They have given that for your study. SAG solver for ridge regression, logistic regression, whatever, and the theory also, everything you can go through, plus the hyperparameters and how they are getting impacted, like maximum iteration. It's going to, sometimes you see this error, right, or warning, the maximum iteration was reached, but you did not reach to convergence, as I was telling you. Sometimes you don't converge. So you have to increase the number of iterations, right? So these are the things. This V stack and H stacks are vertical and horizontal stacking, which is a part of NumPy. Okay, yeah, tell me. Someone was asking something.
Sir, ये जो sir, ये जो file है, is this in the language of Python? Yeah, this is called a separate language in which it is written in the backend.
नहीं, ये तो सब Python है ना?
Yes, sir. So
Everything
ये
is
Python का backend है.
Yeah, this is the backend for Python. Like when you work on Java, you download the jar files, right, from internet. Those jar files are also written in Java.
Yeah.
Okay, but the kernel, the Python kernel, okay, that is written in C++. This thing, this kernel, okay, this kernel which you restart, right? Like you say compiler or interpreter, right? From computer science field, if people are, so they understand the compilers and interpreters. So the Python compiler or interpreter, Python is an interpreted language, okay? Python is not a compiler language. I think you know this. Python is not compiler based language. It is an interpreted language, right? I hope you guys are aware about this. Python is not a compiler language. It is an interpreted language. Java is a compiler language. Okay. Java is a compiler language. Python is not. Okay. So, so the compilers, interpreters, they are all like, they may be written in different languages. That's fine. Like for Python, the kernel, the core heart of Python is written in C++. That's why yesterday I was telling to some of you to install Visual Studio with Visual Studio C++. Otherwise, some packages, they don't work. Okay, so you have to have Visual Studio C++, Visual Studio and C++. You need these things for some of the packages to work correctly. Okay, going back to this thing. For Mac, there are various other notebooks. I'll tell you. Meanwhile, you can try WordPad. Try WordPad, but yeah, there are far better ones. I'll tell you. Okay. Okay. So this is about the core core programming concepts that we are talking about. Okay. So we create the object. The object calls the constructor. Constructor do the initial work. Init means initial work. And once all those things are done, we move into the next step, which is fitting the model on the data. You guys have already done it. So once you fit the model, one second. So once you fit the model, my work is done. But now what I want is I want different parameters of this trained model. Model train हो गया, but अब उसकी accuracy कितनी है, train accuracy कितनी है, उसने मेरे coefficients की क्या value निकाली है, intercepts की क्या value निकाली है, right? तो अब मुझे ये equation बनानी है, y is equal to beta naught plus beta 1 x1, right? So what I need beta 1 and beta naught, where beta naught is the intercept and beta 1 is the coefficient, right guys? So what I will do, I will simply run this. So it's doing what? It's printing me the intercept and then it's printing me the coefficient for all the input features. Here I can see which one are important, which one are not, by simply looking at their slopes. But the point here is the slopes are too high, okay? But when I will give you the example of ridge and lasso, you will see these values going near to 0. अलग अलग होंगी सबकी वैल्यू, but somewhere near to 0. जैसे इसकी वैल्यू देखो कितनी ज्यादा है, 11,000. Definitely this will overfit the system. Okay, या ये 11,000 है. This will determine the output. I don't want that to happen. This will have the least importance, right? I don't want that to happen. Some have positive correlation, some have negative correlation. That's fine. My model has a bias of 971, the initial error, which is also too high. मतलब इसका ये हुआ कि अगर किसी को भी मुझे इंश्योरेंस मतलब कोई मेरी इंश्योरेंस पॉलिसी अगर लेगा, उसका किसी भी फीचर की मुझे पता हो ना हो, मैं उससे 971 का इंटरेस्ट तो लूंगा ही लूंगा. अगर कल को तुम मेरे पास आते हो कि मुझे एक नई पॉलिसी ये वाली लेनी है, इंश्योरेंस पॉलिसी, तो इंटरसेप्ट का मतलब क्या है? इंटरसेप्ट का मतलब है कि भैया देखो 971 रुपए तो तुम्हें देने ही देने पड़ेंगे इस पॉलिसी के, लेकिन ऊपर से कितने देने हैं वो तुम्हारे फीचर पे डिपेंड करता है। ये हो सकता है कि तुम्हारे फीचर की वजह से बढ़ भी सकता है, घट भी सकता है। ठीक है, तुम्हारे अच्छे फीचर्स हैं तो इसमें थोड़ा और बेस अमाउंट ऐड हो जाएगा, अदरवाइज अगर तुम्हारे फीचर्स अच्छे नहीं है तो बहुत ड्रास्टिकली तुम्हारा इंश्योरेंस प्रीमियम बढ़ जाएगा। बट इतना तो तुम्हें देना ही देना है विदाउट नोइंग एनीथिंग अबाउट यू। ओके, अगर मुझे किसी भी फीचर की कोई नॉलेज नहीं है तो दैट इज व्हाट योर इंटरसेप्ट नॉर्मली टेल्स, द बेस वैल्यू। सो नाउ व्हाट आई विल डू, आई वांट टू सी कि ये कॉलम्स हैं कौन से, राइट? सो ट्रेन डॉट कॉलम्स आई विल सी, ओके ये एज कॉलम है, ये बीएमआई कॉलम है, कौन सा कॉलम कौन सा है। मैं इस आउटपुट को इस आउटपुट से कंकैटिनेट कर सकता हूँ, एक टेबल बना सकता हूँ की वैल्यू पेयर का, जहां पर एज विल बी की, दिस विल बी वैल्यू। आई कैन क्रिएट इट लाइक अ टेबल, this will become my keys and this will become my values, but that's fine। तो अभी मेरी इक्वेशन बन गई। अब आप लोग अगर आप लोग मुझे इससे पिकल फाइल बनाकर दे दोगे या मुझे पीएमएमएल फाइल बनाकर दे दोगे, आई विल बी मोर देन हैप्पी टू गो अहेड। बट अभी तक आपने इसको इवेल्युएट ही नहीं किया है तो इसकी पिकल फाइल बनाने का कोई फायदा नहीं है। बट इफ यू वांट यू कैन क्रिएट अ पिकल फाइल। तो मुझे इसका थोड़ा सिंटेक्स देखना पड़ेगा। इफ यू वांट इट्स वेरी सिंपल, एज आई टोल्ड यू, कोई रटने की जरूरत नहीं है सिंटेक्स। pk.dump the object and the file, the protocol it's fine, fixed imports true, so I'm not doing a dump right now, but this is how we will be doing it। I will tell you later, but this is how you will do it। Import pickle as pk, that's it। pk.dump, dump what, this object inside this file, that's it। अब ये कह रहा है कि ये फाइल को राइट मोड नहीं है। अगर आप एरर देखोगे, हमेशा एरर को देखो, आपको एरर से पता लगेगा क्या कह रहे हैं। फाइल मस्ट हैव अ राइट एट्रीब्यूट, मींस ये फाइल जो है राइटेबल होनी चाहिए। अब राइटेबल का मतलब है कि या तो इस फाइल को पहले मैं ओपन करके रखूं यूजिंग द फाइल मेथड, file package, I can open this file, file.open, I'm not doing it right now, and then I can dump this, and then I can do file.close। I'll tell you that later, but you have to do it। Okay,
सर ये
पहले
पिकल
file
एक्सटेंशन नहीं होगी कोई?
कोई जरूरत नहीं है, that's fine। It's all about the content। Extensions does not matter, but if you want you can put .pickle, .pk, .pkl, that's fine करती है। अब आप किसी भी फाइल को किसी स्पेसिफिक टूल से ओपन करना चाहते हो, extensions matter only at that time, interested only in the content, extensions does not matter। You want those tools and those understand only particular extensions। only go to this file, right click it and open it. But if you can open it through Notepad++. Okay, so extensions are when you're using specific tools which understand only specific कहाँ जा रहे हो? We got that 7 definitely. We can we can try to convert this. We can change the solver or the algorithm SAG, SAGA, right? Which we talked yesterday, or we can move to ridge or lasso. Okay, that is one thing. Now I am trying to score this model using X test and Y test. And now the point is I should try to understand what is the error. Input contains NaN, okay. Entities or value that are too large for this particular thing to work. If you ideally always go through all of these and you will be able to solve it. So definitely we will solve it. So now I'm just commenting it, the second point. So what we need to now check is कि आखिर मेरा X test और Y test है क्या जिसने वो error दी. So this is my X test data. Check if there are any nulls. See, you can see the nulls, right? That's why that error. So I told you, right? We checked that the nulls were introduced in the data. So we can definitely treat this or maybe handle it in a different way. But yeah. So I'm moving ahead right now.
Sir?
Okay. Yes?
So, but these
Yes.
nulls are treated in EDA itself. जब हम EDA करते हैं वो तो nulls तभी treat हो जाते हैं train test along with the training. जब हम train करते हैं model को.
नहीं. It depends कि आपने null treat तो कर दिया. मान लो आपने पहले null सारे हटा दिए थे, for example. But जैसा मैंने बोला, आपने कोई ऐसा computation किया जिसने null introduce कर दिए. There can be certain mathematical formulae which can generate null values. Okay, during your EDA, you use certain methods, maybe for creating a derived variable or something, and nulls got introduced in your data, but you didn't check it later. So that's not the right thing. You should check it. So this is why I was telling you at this point. Finally, even before starting the ML process, I am again checking for nulls and NAs, and I have to treat them also. कि भाई ये क्यों इंट्रोड्यूस हो गए मेरे डेटा में, ऐसा मैंने कौन सा फंक्शन यूज किया था. ठीक है, तो मतलब मैंने क्या किया है, एक्चुअली ऊपर बहुत ज्यादा ईडीए किया हुआ है इसमें, तो किसी की वजह से ये इंट्रोड्यूस हो गया. तो जस्ट टू टेल यू दिस थिंग, आई हैव केप्ट इट हियर. तो फिर हमें इसको भी अलग से देखना पड़ेगा कि हमने वो जो स्टेप किया था जिसने नल इंट्रोड्यूस किया है, क्या वो स्टेप सही था, क्या उसकी जगह हम कोई ऐसी स्टेप यूज कर सकते हैं जो कि नल इंट्रोड्यूस ना करे, या फिर क्या हम इन्हीं नल्स को ट्रीट कर सकते हैं क्योंकि 4-5 नल्स मुझे दिख रहे हैं, तो मैं क्या इनको 0 या 1 या कुछ वैल्यू डाल सकता हूँ. यहाँ बहुत सारी अप्रोच है. इट डिपेंड्स ऑन द प्रॉब्लम दैट आई एम ट्राइंग टू सॉल्व. ओके, So all the EDA depends on that kind of data that you have. So null, I handled it, but it got introduced due to some other activity. Okay. And that was also a part of EDA. EDA के बाद null introduce नहीं होता है डेटा में. वो मेरा कोई कॉम्प्लेक्स EDA था जिसने फर्दर null इंट्रोड्यूस कर दिया, तो मुझे उसको भी हैंडल करना होगा. Okay. So that's why that error you were seeing, right? हाँ बोलो.
सर जैसे हम ड्यूरिंग ट्रेनिंग जैसे नल्स को हम मीन से या फिर मून से रिप्लेस कर देते हैं, तो इस केस में हम वो अप्लाई कर सकते हैं. टेस्ट
क्या करते हैं हम, नल को किससे रिप्लेस करते हैं?
मीन या मून से रिप्लेस कर देते हैं या फिर माइस लगा देते हैं, समथिंग लाइक दैट. तो हम टेस्ट को नहीं कर सकते.
देखो आपको नल डेटा हैंडलिंग पूरे डेटा पे करनी होती है, चाहे वो टेस्ट डेटा हो चाहे ट्रेन डेटा हो, राइट?
यस सर.
नल हैंडलिंग तो, लेकिन जो भी नल हैंडलिंग आप कर रहे हो वो कंसिस्टेंट होनी चाहिए. मतलब ट्रेन डेटा पे जो हो रही है वही टेस्ट डेटा पे होनी चाहिए. आप चाहे मीन करो, मीडियन करो, मोड करो, आप चाहे मतलब माइस यूज करो. देयर आर KNN इम्प्यूटर्स, देयर आर फर्दर इम्प्यूटर्स. लीनियर रिग्रेशन यूज कर सकते हो मिसिंग वैल्यू इम्प्यूट करने के लिए. देयर इज फॉरवर्ड इम्प्यूटेशन, देयर इज बैकवर्ड इम्प्यूटेशन. मतलब किसी भी वैल्यू को उसकी प्रीवियस वैल्यू से इम्प्यूट कर सकते हो जस्ट बिफोर, राइट? तो बहुत सी अप्रोचेस हैं, बट यू कैन यूज दैट फॉरवर्ड बैकवर्ड इम्प्यूटर और मे बी लीनियर रिग्रेशन. माइस इज नथिंग बट एल्गोरिथमिक इम्प्यूटेशन यूजिंग KNN और लीनियर रिग्रेशन. तो आप वो भी यूज कर सकते हो, कुछ भी कर सकते हो.
सर पाइथन में माइस का पैकेज कौन सा है? बिकॉज़ वी
पाइथन में भी है. नहीं किया कोई नहीं, मतलब ये रहा ना. This is there, right?
Yes.
See, you have KNN imputer, you have iterative imputer, you have simple imputer, right? So you have all these things. So it's similar to mice. Simple imputer, missing indicator, KNN imputer. So we use these two, either simple imputer or KNN imputer. That's it. This uses linear regression, this uses KNN. Use either of these two, nothing else. Okay. So this is the equivalent of mice.
माइस में जैसे जो मिसिंग वैल्यूज होती है उनका डेटा एक्सप्लोर करके फिर उनके हिसाब से वैल्यू कंप्यूट की जाती है. So these functions do the same thing.
मतलब देखो ये जो फंक्शंस होते हैं वो अपने आप में इंटेलिजेंट नहीं होते. मतलब किस तरह का इंप्यूटेशन करना है वो तुम्हें डिसाइड करना होता है. ये तो सिर्फ वो एल्गोरिथम चला देंगे जो इंप्यूटेशन के लिए यूज होना है. अगर हमने KNN इम्प्यूटर कहा तो KNN इम्प्यूटर क्या करेगा कि किसी कॉलम में अगर मिसिंग वैल्यू है तो वो उसके नियरेस्ट नेबर्स की जो भी वैल्यू होगी उनका एवरेज ले लेगा बस. लीनियर रिग्रेशन मॉडल बिल्ड करेगा. लेकिन अब तुम्हें सोचना है कि मेरे प्रॉब्लम स्टेटमेंट में KNN इज बेटर और सिंपल इम्प्यूटर इज बेटर. इन चीजों का कोई शॉर्ट आंसर नहीं होता कभी, बिकॉज दे डिपेंड्स ऑन द डेटा एंड द नॉलेज ऑफ माय डेटा. ओके, तो दैट्स व्हाई डेटा साइंटिस्ट प्रॉब्लम स्टेटमेंट. या गो अहेड.
सो वो हम फर्दर एक्यूरेसी चेक करके भी हम देख सकते हैं कि कौन सा
वही होता है. मतलब एज अ डेटा साइंटिस्ट आपका काम ही वो है कि आपको टूल्स बहुत सारे पता है, लेकिन कहाँ क्या फिट होगा वो आपको एक्सपेरिमेंटेशन से ही पता लगेगा और एक्सपीरियंस से. मतलब कई बार आपका एक्सपीरियंस आपको सीधा ही बता देगा कि इस केस में ये यूज होना चाहिए, बट उसका कोई वो नहीं है कि आपने इंटरनेट से पढ़ लिया और आपको पता लग गया. इट्स ऑल एक्सपीरियंस एंड टाइम. ओके, two things, experience and experiment. That's it. Okay. So moving ahead. So I'm just trying to predict the output here. What's happening? Okay, that NAN thing is creating a problem for me. But anyways, it's fine. So here I'm just trying to tell you about how linear regression works before we jump into further things. So you predict it, you get the output, and then you have this sklearn matrix from sklearn you import the matrix, and this folder further contains the method like r2 score. तो आप ये भी यूज कर सकते हो, या फिर वो ऊपर जो स्कोर वाला फंक्शन था वो भी यूज कर सकते हो टू कैलकुलेट द एक्यूरेसी। तो यहाँ पर मैंने कुछ एक्यूरेसीज कैलकुलेट करके रखी हैं, आई थिंक 69, 75। अच्छा, ये तो डिसीजन ट्री की है, लीव इट। ओके, सिमिलरली देयर आर फॉर्मूले फॉर एमएससी एंड आरएमएससी, आप वो सब भी यूज कर सकते हो। लाइक देयर इज दिस फॉर्मूला फॉर एमएससी, और आरएमएससी के लिए हमें एमएससी के बाहर स्क्वायर रूट लगाना पड़ता है, राइट। आरएमएससी का डायरेक्ट फॉर्मूला नहीं होता, इसलिए हम स्क्वायर रूट ऑफ एमएससी फंक्शन यूज कर लेते हैं। ओके, तो दैट्स फाइन। लेट मी जस्ट चेक समथिंग। ओके, one second guys. तो ये मैं अभी लीनियर रिग्रेशन मॉडल ही चला रहा हूँ। ओके, तो गाइज इससे पहले जो मैं चला रहा था यहाँ पे, आई चेंज दिस नेम। एक्चुअली यहाँ पे मैंने ईडीए बहुत ज्यादा किया हुआ है, तो इसलिए वहाँ पे कुछ इश्यूज आप लोगों को दिख रहे हैं, नल्स वगैरह इंट्रोड्यूस हो गया है। तो मैं अभी नॉर्मल विदाउट ईडीए वाले पे जा रहा हूँ, जिसमें बहुत ही बेसिक ईडीए किया हुआ है। तो लेट मी शो यू दिस विद वेरी बेसिक ईडीए। वहाँ पे मैंने एक्चुअली तीनों तरह। हाँ
सर, एक बार इसका सेल 26 जिसमें कुछ वैल्यूज जो 2 है, जिसमें आपने इंश्योरेंस का बोला था सर, यही सेल 25 जो है
करेक्ट
सर, इसमें क्या ये कोड और को समझा दो एक बार, ये वाला कोड।
मतलब लीनियर रिग्रेशन का कोड।
यस सर।
यार एक मिनट। अच्छा देखो, दोज ऑफ यू हु आर आस्किंग मी कि ये डेटा कहाँ से मिलेगा, तो मैंने ये नोटबुक आपको बता दिया है ना। आप लोग मेरी गिटहब अकाउंट पे जाके ये नोटबुक लीनियर रिग्रेशन की वहां से ले लेना, वहां पे ये लिंक है, यहाँ से वो फाइल डाउनलोड कर लेना। नहीं तो आप मेरे गिटहब अकाउंट पे अगर जाओगे तो वहां पे मैंने सेपरेटली एक डेटा सेट फोल्डर भी बनाया हुआ है, उसमें ये सारे डेटा सेट्स हैं, इंश्योरेंस डेटा एंड ऑल। इफ यू गो हेयर, so here if you go in data science with Python, you don't need to go to any website guys. If you want to clarify some concepts, go here, there are some PPTs and all, very few. If you need data, I have all the data files for you here, whether you want this Titanic and all. But if you are not getting any file here, you will get the link for that within the notebook. Okay, just try to open those notebooks and you will be able to see the links within those notebooks. Okay, in all of these. So I created some pickle file .pkl, right? Someone was asking, right? So you can put .pkl as the extension, but that's not mandatory. As I told you, you can do that. So here, so I'm just directly using the pickle file by loading it, as I told you, right? मान लो किसी ने मुझे अपनी pickle file दी, मैंने सीधा सीधा उसको लोड किया और मेरे पास आउटपुट आ गया, मुझे कुछ नहीं करना, कुछ ट्रेनिंग नहीं, कुछ नहीं, सीधा मैंने प्रेडिक्शन कर दिया। ओके, did you guys saw this stat which is on my screen, guys? Please tell me, have you seen the stats? Yeah, definitely, guys. Please fork my repo, star it. Those who are aware about it, definitely use my repo, fork it, whatever you want to do it. Perfect. So you guys have seen this, right? This is the linear regression stats, right? OLS, R square, adjusted R square, F statistics and all. The number of observations and then each feature which was passed into the model, right? And what is their p-value. So you can see that definitely which one are significant, right? And which one are not significant. 0.05 से कम जिसकी भी वैल्यू है सब सिग्निफिकेंट है, ऊपर ये वाला सिग्निफिकेंट नहीं है, इसको हम ड्रॉप कर सकते हैं कॉलम को। तो जो फॉरवर्ड सिलेक्शन बैकवर्ड सिलेक्शन मॉडल्स होते हैं वो ऐसे ही करते हैं, वो जो काम के नहीं होते उनको ड्रॉप खुद ही कर देते हैं। यहाँ पे आपको डेटा की स्क्यूनेस और कर्ट्यूसिस की वैल्यू भी मिल रही है, which is another important thing. I hope you guys are aware what is skewness and kurtosis. Guys, ping me. What is skewness and what is kurtosis? Okay, okay, no problem. These are some statistical concepts. So whenever you are getting the data as part of your EDA, you have to check for skewness and kurtosis also. For example, let me take one column. I'm not going into detail, but for example, I'm taking age, okay, the age column, and I'm plotting a distribution graph, and the distribution graph is say coming something like this, okay. This is known as even a bell curve. Okay, so if you're getting something like this is a normal distribution. Now what may happen is I get another data in which I also have the age column, but when I plotted that, I am getting a graph maybe like this, or maybe a very steep peak, maybe like this. तो जो हम डिस्ट्रीब्यूशन टेस्ट की बात करते हैं, टी टेस्ट एंड ऑल, उसमें भी ये चीज आपको हेल्प करती है कि एक्चुअली आपको मैंने इंडिया के लोगों का भी डेटा दिया, अमेरिका के लोगों का भी डेटा दिया, ठीक है। जब हम टी टेस्ट वगैरह की बात करेंगे तो इंडिया के लोगों का आपने एज ग्राफ प्लॉट किया, अमेरिका के लोगों का प्लॉट किया, से चाइना का प्लॉट किया, आपने 3 ग्राफ प्लॉट किए उनकी डिस्ट्रीब्यूशन कंपेयर करने के लिए कि अमेरिका में लोगों की एज किस रेंज में है, इंडिया में कैसी है, चाइना में कैसी है. And you saw these 3 graphs, one for India, say Japan and China, whatever. So just looking at this graph, you can get too much information. Like, अगर मैं कहता हूँ मान लो ये इंडिया का है, for example, and here I am having age, okay. This is definitely the mean value, the central value, okay. So what I can identify from this first graph is the mean or the central value, the median value, is where the maximum population lies, okay. So say if this value is 30, we can say in India there is young population, too much young population, okay, and lesser people who are above and below the 30 years of age. But India is having a young population, very high peak. When you look at this graph, say this is for America, you will see definitely there also we have the say its top is somewhere like this. So the maximum people there are somewhere around say 35. So we can say कि अमेरिका में majority of the population is 35 years old. That means India holds the younger population as compared to America. Okay, but even the total population by density is more in India. If you look at even this peak, right, this peak, that will tell you कि India में the density is higher. Okay, but now come to this third graph. इस थर्ड ग्राफ को मैं थोड़ा अलग से बना के दिखाता हूं. Let me plot it. So the third graph, the older population more in this particular country as compared to the younger population. If this is my median, say for example this is 40 compared to the younger people in this country. So this is a skewness example. Okay, this is a skewness of multiple types, like positive skewness and negative skewness. This is the base graph. This is having a higher peak and this is having a lower peak. So these are the examples of cultuses. It is known as different kind of cultuses: platycultic, leptocultic, and meso.
बहुत सालों तक उसे ढूंढा
Okay, ठीक है. So you guys can get all this data and all the, for example, you can get it from here, download it from this Kaggle site. Okay, I pinged you. You can get it from there. Okay. So definitely, if you guys see, my linear regression model is 74 and 75. So overfit तो नहीं है ये definitely. थोड़ा अंडरफिट मैं इसको कह सकता हूँ क्योंकि 74 ही एक्यूरेसी 75 की आ रही है, तो आई विल ट्राई सम बेटर मॉडल. ओके, सो बिकॉज 74 इज नॉट दैट गुड बट स्टिल इट्स फाइन. मतलब just a moment guys. Yeah, okay, so till now the accuracy, model accuracy and all those things. दो चीजें मतलब accuracy और error हमें हमेशा चेक करनी होती है. Error हम दो मॉडल को कंपेयर करने के लिए यूज करते हैं. Accuracy खुद ही उस मॉडल के बारे में बताती है कि ये मॉडल कितना एक्यूरेट है. एरर यूज करके हम दो मॉडल्स को कंपेयर कर सकते हैं कि कौन हमें कम एरर दे रहा है, क्योंकि एरर अपने आप में आपको ज्यादा कुछ बताएगी नहीं. अगर एक ही मॉडल है तो एरर वी यूज टू कंपेयर मॉडल्स एंड एक्यूरेसी वी यूज बोथ फॉर कंपेयरिंग द मॉडल प्लस टू डिसाइड वेदर दिस मॉडल इज गुड और नॉट. ओके, बट एज आई वाज टेलिंग यू कि स्टैट्स मॉडल भी यूज किया जाता है लीनियर रिग्रेशन के लिए, क्योंकि sklearn आपको उतने डिटेल स्टैट्स नहीं देता जो आपको स्टैट्स मॉडल देता है. इसीलिए व्हाट यू कैन डू इज, आई एम पिंगिंग यू एनीवेज दिस थिंग, बट यू कैन यूज माय नोटबुक. You import the statsmodel.api package as SM, and then you have this OLS, which is like the ordinary least square. You pass on your y data and x data. This is see, ऊपर आप क्या पास कर रहे थे, आप x train y train पास करते थे. यहाँ पे y train x train, यहाँ ऑर्डर बदल गया because it is somewhat similar to R syntax, where what you used to give y tilde and then you give to x1 plus x2, right, like this. So that's why it's y train x train. Whereas if you look some small things to note. Normally if you use sklearn, they give x train y train always, but OLS uses y and x similar to R. Okay, because it's a older format and it works like that. So I did fit. अब देखो यहाँ पे फिट मेथड के अंदर वैल्यू नहीं जा रही, यहाँ जब ऑब्जेक्ट बना रहे हो तभी आपको डेटा पास करना है. फिट किया और उसके बाद समरी देख ली मॉडल की. समरी आपको इसकी भी मिल जाती है, बट OLS की समरी ज्यादा डिटेल्ड है, जिसमें आपको खुद से आर स्क्वायर, एडजस्टेड आर स्क्वायर वैल्यू, AIC BIC, राइट. AIC BIC आर इंपॉर्टेंट है. किसी भी मॉडल के बारे में AIC BIC बहुत इंपॉर्टेंट होता है. अकाकी इंफॉर्मेशन क्राइटेरिया एंड बाइजियन इंफॉर्मेशन क्राइटेरिया. गाइस, कैन यू टेल मी कि AIC should be high or low for a good model? AIC should be high or low? Guys, are you aware about AIC BIC? Correct, Aditi. Right, AIC should be low. Yeah, AIC BIC values should be lesser. There are multiple information criteria like AIC BIC. There are two more, I think. So 3 or 4 different types are there. So mainly we use AIC BIC, and they should be low. If you have to compare two models, number of observations, as in the number of records that passed into the model, that is important. This DF is something known as degree of freedom. For errors and for the model, you guys can read about degree of freedom. First, try to comprehend what is degree of freedom from mathematical point of view. Then you can understand from model's point of view. It's a mathematical term, degree of freedom. Okay, or statistical term rather. What is degree of freedom? Okay. P values, definitely I can see estimate the likelihood of a model to predict or estimate the future values. Yeah, Guljar, correct.
Sir?
And one second. And this is the confidence interval between 25% to 97%. Yes, tell me.
Sir, to AIC BIC, to we calculate when we use logistics. So we need to look at that in this model. Linear regression जो हम apply कर रहे हैं तो.
AIC BIC is not model specific. AIC BIC are not model specific. They are statistical parameter to tell the correctness of your model. So you can do it for any model. Like R square is not specific to a particular model. It's the accuracy, and you can calculate it, right? R square or adjusted R square. For regression models. For classification models, definitely we have confusion matrix, which is different. Okay. बट दीज थिंग्स आर नॉट स्पेसिफिक कि ये लॉजिस्टिक में ही चल सकता है या ये ऐसा कुछ नहीं. ओके और अगर आपको ज्यादा ही इंटरेस्ट है तो आप AICBIC का फॉर्मूला देखोगे तो आपको खुद ही क्लियर हो जाएगा कि ये प्री इसके लिए क्या प्री कंडीशंस होनी चाहिए, कौन सा मॉडल इसको सपोर्ट करता है कौन सा नहीं करता. इफ यू जस्ट सिंपली लुक एट द फॉर्मूला यू विल गेट टू नो. ओके क्योंकि मान लो फॉर्मूला आपका ऐसा है जो कि न्यूमेरिकल वैल्यूज को ही सपोर्ट करता है तो आपको पता लग जाएगा कि ये वाले फॉर्मूले में कैटेगोरिकल फीचर पे या कैटेगोरिकल टारगेट पे लगा ही नहीं सकता है. तो फॉर्मूला की नॉलेज वहां आपको काम आती है. कब AICBIC चलेगा, कब R² चलेगा, कब कंफ्यूजन मैट्रिक्स चाहिए. ओके सो इफ यू लुक हियर मैंने यहाँ पे लिखे हुए हैं AICBIC के फॉर्मूले, but yeah you can go through it and into log likelihood twice of k where these represents your number of observations and number of features. So I built my own AICBIC formula. There is no AICBIC formula. Everything is on GitHub. Okay, all the code is on GitHub. Just search by linear regression and all, so you can calculate AICBIC and all like that. Okay, but the important thing is let's open the OLS from the backend. Okay, let's open the OLS from the backend. किस पैकेज में जाना होगा मुझे यहाँ पे गाइस, कैन यू पिंग मी? SQLN में तो नहीं जाना है. OLS किस पैकेज में है गाइस? OLS के लिए किस फोल्डर में जाना है मुझे? वेरी गुड. सो स्टैट्स मॉडल इज देयर. Okay, go inside it. Now what I want, OLS, right? Okay, stats model.api, right? So further API folder. Okay, so API is not a folder here, rather it's a class, it's a file. So I'll open this file. Within this I need to search for OLS. So if you see, here is the OLS, GLS, WLS, ordinary least square, generalized least square, and weighted least squares. Different models. We only talk about OLS. So OLS is this thing which is coming from a regression.linear model. अब देखो मुझे OLS यहाँ पे नहीं मिल रहा गाइस, तो उसका तरीका क्या है? ये कहाँ से इंपोर्ट किया गया है? रिग्रेशन फोल्डर के अंदर, लीनियर फोल्डर में. लेकिन ये जो डॉट लगी है ना यहाँ, इस डॉट का मतलब ये है कि जिस फोल्डर से आपने ये फाइल खोली है, API.py फाइल जहां से खोली है, वहीं पे ही ये रिग्रेशन नाम का फोल्डर ढूंढना है आपको. क्योंकि डॉट मतलब होता है करंट डायरेक्टरी. करंट डायरेक्टरी मतलब जहां से ये फाइल खुली है उसी जगह पर एक रिग्रेशन नाम का फोल्डर होगा. सो लेट्स सी, ये फाइल कहाँ है? यहाँ पड़ी है, यहीं पे ही पैरेलली रिग्रेशन नाम का फोल्डर. इसके अंदर जाता हूं, यहां पड़ा होना चाहिए लीनियर मॉडल, ये रहा. अब इस लीनियर मॉडल को खोलता हूं, इस लीनियर मॉडल सर्च करता हूं. So I'm just trying to search for the OLS class. So here is this class OLS. So the OLS class is there, and let's see what it's do. OLS class has the score method or the score function. 。   。   。  . 。 . 。 . 。 . 。 . . . 。 . 。 . 。 . . . 。 . 。 . . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 those who comes from the mathematical background, they must know what is Hessian matrix. Hessian matrix is something important when it comes to logistic regression. There is something known as Hessian matrix. It's for mathematical people. Now, what I want to show you guys is there is a AIC method inside this model, and it is returning you this formula. So guys, this is the formula which the model is using to calculate AIC, and similarly it is using another formula for BIC. So you guys can study these to know what is the formula used by the model for AIC BIC. Like, these are my formulas, but these are the model's formulae. So there might be slight difference between the two, and difference will only be in the case that how it is calculating this. For example, the calculations that model is doing, that might be a bit different, but returning with the same value. मतलब log likelihood का फॉर्मूला जो मॉडल यूज कर रहा होगा वो मेरे फॉर्मूले से अलग हो सकता है, बट अल्टीमेटली जो AIC का इम्प्लीमेंटेशन है वो मेरा और उसका सेम ही होगा, बट यू हैव टू जस्ट चेक. तो मेरा पॉइंट ये था कि AIC BIC के फॉर्मूलों में स्लाइट डिफरेंस हो सकता है अक्रॉस मॉडल्स, कि लीनियर रिग्रेशन और लॉजिस्टिक में कुछ स्लाइट डिफरेंस हो सकता है फॉर्मूले में, नॉट मेजर डिफरेंस, आइडली दे आर सेम, बट इट इज लाइक मल्टीपल मॉडल सपोर्ट्स AIC BIC. बट इफ यू वांट कि वो क्या एक्चुअल फॉर्मूला यूज कर रहे हैं, आप पीछे okay. So this was about the linear regression with OLS and simple, which I just wanted to revise here. But now let's jump into this thing. Okay, I think we are over time, so 1 second guys. So tomorrow we will start with the implementation of ridge and lasso. We will quickly complete these two, and then we'll jump on to the next model. So we will talk about these two models. 1 second. How the output is getting changed, okay, and what are the hyperparameters, what are the things that you need to actually change. Okay, so tomorrow we will start with this ridge and lasso, and this alpha here is the parameter which is doing the regularization. Okay, so meanwhile guys, please read more about ridge and lasso. Remember that ridge and lasso are the way to avoid the overfitting. That means ओवरफिटिंग जब होती है आपकी ट्रेन एक्यूरेसी ज्यादा होती है, टेस्ट एक्यूरेसी कम होती है. तो रिज लैसो से क्या होगा? रिज लैसो से ये नहीं है कि आपकी, देखो ये हम मैट्रिक्स बनाते हैं, सी अंडरस्टैंड दिस. एक नॉर्मल लीनियर रिग्रेशन मॉडल will have high train accuracy and may have low test accuracy, means overfit. But a ridge or a lasso, it may have slight less train accuracy. Like if you are getting 97 here, it may be 92, but that's fine, because here if earlier I was getting say 7, here I am going to get maybe 88. Okay, so understand this, that the regularization generalized, and the whole purpose of our machine learning is to build generalized models. That's why in R you were talking about GLM, maybe linear models and generalized linear models in R. GLM, generalized linear models. So regularization actually is a step towards generalization only. It helps you achieve generalized models. Generalized models का मतलब क्या है कि they are generalized, means they are not specific to train data. They are more generalized to work on unknown, unseen data like test data. So that's where we say generalization. मतलब अगर मैं कहता हूँ कि I am specific to a particular field, then I may not be good in other fields. But if I am having generalized knowledge, okay, जैसे होता है कि general MBA या general BSc, they are not specific in any field. They know about all the fields. But if you become specific, it may be that you are good in a particular case, but not in all the case. So that's where our models should be more and more generalized, not specific. And regularization is a step towards generalized models. So your train accuracy might be slightly lesser than the OLS model, but you will avoid the overfitting. Okay, that's the crux of what we discussed today. Okay, this time. So with that, I'll pause here today, and tomorrow we will start to implement this, and then we'll see either some of the statistical tests as we were talking about, skewness, cut usage, and t-test, or maybe some other model with its own mathematics. Okay, guys, please revise all these things and read more about region lasso. Bring your questions tomorrow, and we'll talk. But remember the formula. Okay, you have to remember the formula for interview. You don't need to remember the syntax, but you need to remember the formula. No, Gulzar, that's what I'm saying. I don't need to send you guys anything. Everything is here. Okay, everything is already there. But yeah, if someday I think that I'm building some new codes for you, I will put that. But so far today I haven't built anything new for you guys. It's already the same, so you guys can access it. Okay, so going forward you guys don't need to wait for me. Just even जो लोग आप लोग जो पढ़ भी चुके हो, for example आप लोगों ने unsupervised learning अगर कर भी ली है, so you can go to this thing and you can study PCA from my content also. Okay, if you're interested in PCA की maths की document है यहाँ पे, what is the maths behind it, and everything is here. Okay. Yeah, tell me.
Hi, Alok.
Any question?
So, Alok this side, Rahul.
Yeah, Alok. Yes, hi.
Hi, how are you?
Good, Alok. So I just concluding the class. So you have a next class?
Not actually next class. I needed to interact with these guys for a couple of minutes. So guys, please stay on the link. Don't leave. I need to have a word with you. So please stay.
Okay. Just 1 second.
Sorry to disturb.
Just give me 1 minute, guys. I'm just pinging you the YouTube link also if you want to go ahead, and then I disconnect. 1 second.